Good. Okay, so we're online on YouTube. Okay, there's Kenneth really thought who is here.
Yeah.
Just join the chat.
Yeah, I'm here.
Okay. David will be coming at it also.
Okay.
Hello. Ken and Grégoire, can you hear me?
Yeah.
Who wants to introduce Louis? Perhaps Kenneth?
Well, I could, although if Hie Young is here,
Yeah,
might.
exactly. That was what I was asking.
Okay.
But do you know if she is coming? Louis?
I thought she was.
Okay, I'm gonna send her a message.
Okay, I'll be on standby for now, waiting.
So Yue Yong is here. Oh, Adele also. Okay, great. So we can start.
Hi, Lou.
Hello.
Hello.
Hi. Bonjour, Adèle.
Bonjour, hey Young. Hi everyone.
Okay. Great. So Yue Yong, do you agree to present Louis, or do you prefer me to do it? How
You can do it. I mean, you're the host.
as you wish, because we were like the consensus. David proposed that you do it, so if you want to do it, it's okay. But if you prefers me,
No, you can do it. I mean,
okay, as you wish. Okay.
Then I guess Ken should do it.
Ah, but
Well, No, I think
Okay, Ken, let's do it. Okay, Ken does it. Okay, good.
oh, you want me to do it? Well, it's gonna be I've never met until just now. So I guess
But
that's
you know a
true.
lot about his background.
Well, I know I the more I look here, the more I realize I don't know. But
Okay, so maybe
but
I'll do it then.
I do know about his work connected to Varela, but okay. Well, go ahead, Gregoire. You know more about knot theory and topology and
No, no.
things like that than I do.
Okay, so okay, let's start. So, like, just 1 second. Okay, so it's the 11th session of PMMC, so Paris Mathematical Models of Consciousness and Cognition. So today we're very happy to have Louis H. Kauffman, who is a mathematician and who's been working on how to make formal the notion of meaning, but also the notion of self, let's say, reflexivity. So like being conscious about one, like being conscious about what is conscious about. So what it is to, let's say, know that you know something or that you feel something, which is in the continuation of the previous talks by Kenneth Williford and also by Alexandre Billion. So today's is real honor for us to have Louis Kauffman here because he will be presenting philosophical insights on these subjects, but also more formal aspects. So we're very happy to have him. So go ahead.
Okay, thank you very much. I'll share screen and begin here. Oh, we don't have the sharing yet.
Grégoire, it's possible that you
Yeah, it's done. It's done.
I try again. Yeah. All right. So let me get this working and then I'll explain what I think I'm about. That visible to everyone and you can hear me?
Yes.
Yes.
Just a moment, I'm adjusting something here. Looking for where my pointer is. I seem to be, let's see. We'll try that again. I see what happens. So there are little bits of things on my screen that I'm trying to arrange, and then presumably when I set the slideshow to playing, most of it is visible to me. Some of it, okay, here we go. So, oh, there we go. So, what I had described in my announcement for you was a discussion about naming and thinking about how self-reference arises in relation to naming. And then I thought better of just doing that and would rather, I think, kind of give you a feel for the sort of thing that I've been investigating for a long time, which is related to being a mathematician and a geometrically, diagrammatically minded mathematician, so that a lot of the thoughts that I have are related to various kinds of diagrams and bits of geometry. And so I'm going to show you a potpourri of thoughts and diagrams and geometry. And in the middle of the talk, we will talk about naming along the lines that I had described to you. But the sort of thing that I spend a lot of time on because I'm thinking about geometrical problems is imagery like this Escher imagery that you see on this first slide, where you might begin with something which is a curious geometrical phenomenon like a Mobius strip, which is what's going on here, and then imaginings that come in relation to it, which in the case of Escher are artistic imaginings and related to the geometry, like he is, as many people have thought about, imagining an ant crawling on the surface of a Mobius band, and of course the top surface is contiguous eventually with the bottom part of the surface, and the ant ends up crawling both on the top and the bottom, so that what is locally two-sided is globally one-sided. But this leads to other thoughts, not necessarily artistic, somewhat logical or extending logical. For example, the thought that perhaps the two-valuedness of whatever logical thinking that I happen to be working with, the black and whiteness of it, is not just controverted by a kind of fading between the black and the white, but that if one were to step back globally far enough, one would find that the black turns into the white and the white turns into the black, as in a Mobius band. And thoughts like that then lead you off into thinking about the structure of form, structure of logic, how distinctions work, and how distinctions don't work. Any distinction that you happen to have made involves you and involves your consciousness and isn't really a perfect distinction after all. You can always find some intermediate place. So all those thoughts come in relation to looking at some geometry or some nexus like that. And so all of this has that quality, for me anyway, and I am going to go through some of it. And we should be able to see by the end that all of the apparently different things that I've been talking about, as I do, are really very closely related to one another. So let me just begin. I begin with a sentence that Heinz von Forster said in an article that he was writing about epistemology and observation. And he said, "I am the observed link between myself and observing myself." Actually, he said, I misquote him here. He said, "I am the observed relation between myself and observing myself." And we could spend an hour just thinking about that sentence itself. I think of that sentence as a kind of an art form, an indication of cybernetics, a way of indicating how to think about what people call second-order cybernetics. And I don't take it as a mathematical definition of the self. But on the other hand, I do take it as a kind of an injunction to take a look at the kind of observing that is going on in the neighborhood of thoughts of self. And there are many thoughts that a person has, and I'm sure you have them similar to mine and different from mine. And one of them, of course, is that when you think of yourself, you realize that you have somehow made a distinction between yourself and yourself in order to speak of yourself. And what kind of a distinction is that? It's certainly a malleable one that goes back and forth between being separate and not being separate, like the Mobius band does in relation to its sides or its central core curve in the previous page. And then I have contrasted that on this slide with a statement by the physicist John Archibald Wheeler, who said, "No phenomenon is a real phenomenon until it is an observed phenomenon." And that sounds like the sort of thing a physicist would say, huh? But he backed that up in a different way than you might think. And I want to show you what he said and how he got to the statement at the end of what he said. And then we'll come back to Heinz. So this is a summary of what I was just saying, and I needn't say it again, except perhaps to read it. Von Forster's sentence points to the recursive and self-pointing nature of the eye of a cognitive observer. Wheeler's sentence points to the universe as a participatory universe. And that's one of the things these two sentences have in common. The eye, how can you cognize the eye without participating in it with your eye? And how can you understand the universe without participating in it? But what kind of participation does Wheeler mean? Well, here's the story he told. Then my turn came, the fourth to be sent from the room so that Lothar Nordheim's other 15 after-dinner guests could consult in secret and agree on a difficult work. I was locked out an unbelievably long time, and on finally being readmitted, I found a smile on everyone's face, a sign of a joke or a plot, and I nevertheless started my attempt to find the word. He was asked to play a game of 20 questions. Suggest a word, they will say yes or no, and eventually, hopefully, to find the word that is being searched for. Is it animal? No. Is it mineral? Yes. Is it green? No. Is it white? Yes. These answers came quickly. Then the questions took longer in the answering. It was strange. All I wanted from my friends was a simple yes or no, yet the one queried would think and think, yes or no, no, before finally responding. And finally, I felt I was getting hot on the trail, that the word might be cloud. I knew I was allowed only one chance at the final word, and I ventured it. Is it cloud? Yes, came the reply, and everyone in the room burst out laughing. They explained to me that there had been no word in the room. They had agreed not to agree on a word. Each one questioned could answer as he pleased, with one requirement, that he should have a word in mind compatible with his own response and all that had gone before. A possibility. Otherwise, if I challenged, he lost. The surprise version of the game of 20 questions was therefore as difficult for my colleagues as it was for me. There was no word in reality. There was no object. The object was created by the question. What is the symbolism of the story? The world we once believed exists out there independent of any act of observation. The electron in the atom we once considered to have at each moment a definite position, definite position and definite momentum. I, entering, thought the room contained a definite word. In actuality, the word was developed step by step through the questions I raised as the information about the electron into being by the experiment that the experimenter chooses to make. That is, by the kind of registering equipment that he puts into place. Had I asked different questions, or the same questions in a different order, I would have ended up with a different word, as the experimenter would have ended with a different story for the doings of the electron. However, the power I had in bringing the particular word cloud into being was partial only. A major part of the selection lay in the yes or no replies of the colleagues around the room. Similarly, the experimenter has some substantial influence on what will happen to the electron by the choice of experiments he will do on it, questions he will put to nature. But he knows there's a certain unpredictability about what any given one of his measurements will disclose, about what answers nature will give, about what will happen when God plays dice. This comparison between the world of quantum observation and the surprise version of the game of 20 questions misses much, but it makes the central point. In the game, no word is a word until that word is promoted to reality by the choice of questions asked and answers given. In the real world of quantum physics, no elementary phenomenon is a phenomenon until it is a recorded phenomenon. The von Forster's eye is an example of an eigenform, a fixed point of operations in a context, and possibly created by that context. Remember the sentence. It was, I am the observed relation between myself and observing myself. Maybe it's only my description of it that it would be so that something would be fixed, but something does come back on itself. I could take a shorter sentence. I am the one who says I. And this is also an eigenform, a fixed point, from a certain point of view. But of course, you may say immediately that if I say I am the one who says I, the second I is quite different from the first. The first I is filled with being, and the second I is only the word. But that's what's being called into question here. What is the relationship between the I as a being and the I as a word? And on the other hand, if we followed it in the direction of the words, it's I equals the one who says I, and the one who says is an operator, and I is equal to that operator applied to I. So at the level of the formalism, at the level of the saying, at the level of the words, there is a fixed point, but at the level of one's understanding, at the level of one's being, it's quite different. And the I at one end of the sentence is very different from the I at the other end of the sentence. On the other hand, at the level of formalism, we have eigenforms where it's a mere matter of fitting, but there's something fascinating about it even so. Like, this sentence has 33 letters. Indeed, it does have 33 letters, if you would count. And so the sentence is true and self-referential and fitting together in that way. The problem I'm considering here is the relationship of observation with self-reference, reflexivity, and eigenform, whatever observation might be. And we're watching how words and forms and what they indicate and one's feelings in relation to them bring names into being, bring forms into being, and bring words into being. So one is going between what one might say being or feeling and words and forms. And one can't let go of either end of that, just as one can't let go of either end of the sentence, I am the one who says I, the being end or the word end. And they come together and the snake bites its tail. In an observing system, what is observed is not distinct from the system itself, nor can one make a complete separation between the observer and the observed. The observer and the observed stand together in a coalescence of perception. From the stance of the observing system, all objects are non-local, depending upon the presence of the system as a whole. It is within that paradigm that these models begin to live, act, and enter into conversation with us. And I mean it quite literally that in the working with models, when you really work with a model, it becomes another being in the conversation. Perhaps it's a being that only you give life to, but it has its living being. I also wanted to introduce a bit of formalism to you that you may have seen before. This is Spencer Brown's mark of distinction. And Spencer Brown made a mathematical leap or a philosophical leap or both by writing a symbol down, not for a number, not for an abstract entity, as we're quite familiar with in mathematics. We we got beyond numbers long ago and write symbols in abstract algebra for anything that we care to, but to go all the way in a certain sense and write a symbol that will represent, to whatever extent it's possible to represent, the act of distinction, which is in back of every possible cognitive situation, that's a leap. And that's what he did. The rest of what he did in his book is tease out some patterns related to that. But this, like the number 2, stands for all possible couples. This symbol stands for all possible distinctions or any distinction, and it itself is designed so that it can be seen as making a distinction between its inside and its outside. So it is iconic to the extent that you see it that way, just like the Roman numeral 2 is iconic for the number 2 since it has 2 strokes. With that, I don't know that you need to read Spencer Brown's book. You can just think about that idea of having a formalism which is so general that there would be a mark in it that stood not for any particular kind of distinction, but just for the concept or the idea of distinction itself, or any particular distinction as well. The universal and the particular coming together at the point of apprehending that form. I already said enough so that we need not comment on this slide. But of course, you, the observer, are coalesced with the mark. From what I said, for you yourself make and create a distinction all the time. And so the mark stands for you or is you in your conversation with it, which coalesces you with it. And then from there, we go to other perceptions, of course, that are going across the boundary between words, formalisms, and perceptions that are related to them. When you are dealing with the mark, you're dealing with your perception of the mark. When you're dealing with words, you imagine that you don't have to deal with the perception, that you only have to deal with whatever the words are referring to, as though that could be separated from the words themselves, which it cannot. But when you deal with some optical illusion like this, you have to face it. What you can literally see on my page are 3 Pac-Man-like entities and 3 partial angles. But you see more than that. You see a white triangle in the center, or at least most human beings do. A white triangle that's not there except in your perception. It's not on the page, but it's very really there for you, for me. Or another example of perception arising in relation to formalism that isn't in the formalism is the Penrose triangle. And what I'm saying about the Penrose triangle is there a question? I know I'm rattling on here and you're wondering where is he going, but let's see.
No, Luis, this is just a mic that was on, but now
yes,
Leonor,
of course.
We're happy to have Leonor Blum with us today, and she just muted her mic, so please continue.
I know. This is Penrose's triangle, and it's a modern exemplar of Wittgenstein's statement that propositions, the form of the proposition shows itself beyond what it can say. And in this case, if you think of this as something like a proposition, it creates something for you, just like the Kinesa triangle in the previous slide, that it can't even say. It says, three right angles placed together, three right angular forms placed together contiguously and continuously in the form of a single object, which appears to be a single object to your vision, or at least it is to mine. But if you were to put your hand across one corner of it, it modifies itself and transforms itself in your vision into a realistic picture of two right angles, which are going off in different directions at their ends in three space. You don't imagine underneath the gray circle that those two fit together. You imagine that the one on the left goes off to the right far above the one underneath, which is going below. But that discrepancy, that singularity, could be anywhere. If you covered it up here, you would see the singularity there. You would not see the triangle, and you would imagine the singular motion of the right angles over there or over here. So the impossibility of it is non-local, and here it is again in its full form. So I want to talk about, so what have I been talking about here? I have been talking about the imaginary, which is a theme which keeps coming back in, or rather what is shown but not said. And the thing that I'm adding to Wittgenstein, maybe, is that often what is shown but not said doesn't even exist, or rather is a created object which is shown, or an imagined object which is shown. I think that this goes on all the time, and it's very evident in mathematical situations that the objects that we're thinking about are idealized and they don't really exist, but we bring them together and hold them just like you hold that Penrose triangle. But I want to go back to the theme of reflexivity and John Wheeler's universe observing itself, and continue with these questions about the nature of the observer. Some of these are just for fun, of course. This is a very good cartoon raising the question of the nature of the observer. And this is a very nice photo raising the question of the nature of the observer. And this is a more meditative form, again, raising the question of the nature of feeling and observation. And this is back to Escher, the Mobius nature of the world of cognition altogether, with the museum wrapping around and containing its own observer. So one can be aware of one's own thoughts, and thought is composed of thought. And an organism produces itself through its own productions. And if we went into the exterior world, a market is composed of individuals whose actions influence the market just as much as the actions of the market influence the individuals. And the participant is an observer, but not objective because of all that mutual influence. And there is no separated objective observer. And so we want to think about reflexive domains where the participants affect the whole and the whole affects the participants. How can you model this sort of thing? And now I'm going to digress and I might have chosen differently if I were doing this, if I were making up this slideshow again, but I'm digressing into a little mathematics where you see this kind of reflexivity happening maybe without the philosophical questions, but related to them. And it is about forms which, by means of the way they wrap around themselves, become stable in the space and form themselves in the space. And I'm thinking of things like knots, like what you're looking at, a knotted wood, not a Penrose triangle anymore, but 90-degree angles that can be quite really made and go around one another, link around one another in that way. But let me tell you a little story about how the science of knots worked and does work. So, of course, it occurs in practical knot work. We know that. It also occurs in artistic work, like Da Vinci's knot here. And there is a long, long history of this kind of weaving. There's something fascinating about the weaving, about the way these little systems of weaving, which maintain themselves by the way that they interact with themselves, work. And so eventually it becomes a mathematical problem. And it took a long time for mathematicians to start thinking about this, even though there is an enormous history of constructions of knotting. And if you think back to the 1700s, the sailing ships were run almost entirely on the basis of how the knotting worked for almost all of the specifics of what goes on in such a ship. But here is an entity, a tube in space, and the question is it knotted or not? Could you deform this and make it unknotted into a circular cylinder without crossing through itself, without tearing it? If you take a piece of rope and tie a knot in it and then punch the ends together, maybe I should illustrate my problem. It's really a kind of problem of self-reference. So let me illustrate before I go into this slide. Just a second. And we'll come back out. So you can see this, right? You can see my rope. And I have some ends to my rope. And I can tie a knot in my rope. And without something extra, of course, this is a self-interacting entity, the knot, but without something extra, the knot can easily disappear because it can slide on down the rope and come off the end. And it's gone. Sorry, you won't see that, but here it is. And if I just flick it slightly, it goes away because it came off the end. But if I take and tie it into the middle of the rope, and then I seal the ends of the rope together, which is a kind of self-reference of the rope, so that it becomes a circular system, then the knot is trapped on the rope through the self-reference of the rope. And it has now its own pattern integrity and will not go away. It can be slid along the rope, and when I do slide it along the rope, I'm having the knot made out of an entirely different part of rope than it was before. So the material constitution of this knot is not the knot. The knot is this pattern, this integrity of pattern on the rope, and the knot won't go away. There's no way for it to go away without cutting the rope or unplugging it from itself. Not so in general. One could tie some other knot on the rope. I will make one just so you can see. I have a square knot here, and I put the rope through the bottom, and then I put it through the top here, and I plug it together, hoping that I have trapped this entity on the rope, closed loop of rope, apparent knot on the rope. But if we begin pulling at it, we find that that apparent entity is not knotted at all. So you have a problem in flexible geometry that could be quite compelling for mathematicians if they decided to get interested in it. How did mathematicians get interested in this question? The answer is, and this is historical, the answer is that in the 18th century, Lord Kelvin, Sir William Thomson, had a theory that atoms, people began to understand there should be atoms, that atoms were vortices in the luminiferous ether, that they were swirls, the ether swirling on itself like this. And it was a very popular theory. And it lasted pretty much until the ether was discredited by the Michelson-Morley experiment and Einstein's work in special relativity. And then after that, one didn't have the ether in the same sense of a fluid that pervaded space. And so the idea that atoms were vortices disappeared. But the dynamics of vortices is still being studied. They just aren't regarded as atoms. Atoms are not understood that way. But after that, because Lord Kelvin communicated with Maxwell and other mathematicians as well, mathematicians began to get interested in these topological problems, and for other reasons began to be interested in topological problems. And topological is a good term for it because it is a kind of logic, but it is about deformation and flexibility. And this guy here isn't knotted. Maybe you've been wondering whether he's knotted or not, but let's find out. I have some sequence here for you. And as you said, I made a quick step from here to here, but it just wasn't knotted. You could imagine going backward and wrapping it up, and it became, it looks like it's knotted, but it isn't. And so that gave rise to the question, how do you analyze mathematically and prove that things like this are knotted? We aren't going to do the those kind of techniques, but also later on, people began to realize that knotted structures can occur at many different levels. Here, for example, is an electron micrograph that, to a biologist who knows how these are made, is a convincing demonstration that the DNA molecule, when it is a closed loop, can be knotted. And the knotting of it is in the form of a diagram produced by the electron microscope. It's a curve which is being drawn in the plane, and you see it going over and under itself in a weaving pattern, and it's a knotted DNA. And you might then, because by that time in the 1980s, when this experiment was done, one had tables of knots. This is a table of the first few knots. You might wonder which one of these knots is that. So one can compare with the tables, rotate it, examine this, and see that it actually is the same as the one labeled 6-2 in the table. If you would compare this little blue knot 6-2 over here with the photomicrograph above it, you'll see that they're topologically similar. Up to a deformation, you can compare them. And other things turn out to be relevant to thinking about DNA. You can use the language of the diagrams for the knots to understand how the DNA can transform under recombination, where recombination means that the strands of DNA are cut and repasted according to some pattern. So these questions started in science with Lord Kelvin, went into the mathematicians who began to build a mathematical science out of it, and then back into various aspects of science. I thought I had a slide here that would work, but apparently I have something which doesn't want to work. It's a dolphin who can make circles out of his blowhole and chase them, but we'll just go on to the next slide. We'll see if those work. In 2012, actual vortices were produced in fluids by Kleckner and Irvine, and they did it by the same way you would blow a smoke ring, only sort of dual to blowing a smoke ring. Have a ring-shaped object and pull it backward through a fluid, and off the edge of it a vortex will occur and will move to the right. If you had a knotted object that you pulled back quickly, then a knotted vortex can occur. Ah, that movie works. There's an unknotted vortex being produced in water by that method. And this is what the apparatus is for producing a knotted vortex, like that. And I see I didn't include the film there, but this pulls down quickly. Ah, there's the film. And there's the knotted vortex being produced. So that's kind of Lord Kelvin's dream in a fluid, but not the luminiferous ether. So there is this back and forth between the imaginary and the real. We imagine the patterns of the knots, but they can actually occur in the apparent physical reality. Now, I made a little digression there, but the digression was about how science also goes back and forth in a reflexive way between what might be and then what can be and then what apparently is and then again what might be, going around and around in a circle like that. But we want to talk about what is a reflexive domain in general. What will it be? And so I try an abstraction on you. A reflexive domain is a space, context, where every object in the context is also a transformation. So you can think of that like a social system of people where what goes on is what those people are and do, and each person is an actor in that space of and is transforming it. So the objects are transformations, and the transformations are objects. And then something can act on itself, and you could define actions. An example, a bit abstract, is to say, all right, suppose that I had some transformation, and I define a new one by letting that transformation act on an X acting on itself. So G acting on X is T acting on X acting on itself. For example, G acts on X by me, being T, thinking about someone thinking about themselves. And then if G acts on itself, then I am thinking about G acting on, I am thinking about G thinking about itself. But G thinking about itself is me thinking about G thinking about itself. So that we found a fixed point. And the fixed point has to do with that nexus of reflexivity and self-reference that can occur if you're thinking of it that way. And it can be external as well. The fixed points are ubiquitous in a reflexive domain, like that. Let's not worry about these, except as artistic depictions of reflexivity and self-reference. And then sometimes one says things like this. a form re-enters its own indicational space. How could that be? But that could be, in this case, where the GG actually re-enters its own space over there as the fixed point. Or this nest of parentheses is sitting inside itself, if it were infinite. And you re-enter yourself when you think of yourself. So we come back to the I am the one who says I. And many recursive forms that everyone is familiar with since the culture of the 1980s brought it forth, like fractal forms of various kinds. I don't want to go dwelling on this. We're all familiar with this, but it's a remarkable thing to be familiar with, right? That originally the mathematicians thought that making things like that was very pathological and not something that people outside of mathematics would be particularly interested in. And people like Mandelbrot turned us around and said, no, these kind of things are everywhere. And then we saw that they were everywhere, and they can also be made mathematically. And you can make drawings of these kinds where you look at the drawing and see that inside the drawing there are copies of the whole if you were to allow it to go to infinity in the right way. But now I want to talk about naming. So let's suppose that we are told that Alice is this person on the right. So I have written Alice points to the person on the right. Alice is the name of the person on the right. But if you were introduced to Alice and told that this is Alice, something else goes on, right? Because the next time you meet her, the name comes right along with her if you've been an attentive learner of the name. And if you meet your friend and you can't remember his name, you get perturbed because the name should come along with the person in your space so that a shift occurs. You, and in my cartoon, you are the little fellow standing there. You are combined with Alice, the name, and when you see Alice, you put Alice's name along with Alice. Of course, you don't write it out there in space, but in that place where you hold Alice in your perception, you hold the name with no distance really between you and Alice. So formally I write Alice name shifted next to person Alice, and that occurs in relation to the being that does the shifting. If we're thinking of people and the way they learn names. On the other hand, symbolically, I might just use a sharp. Sharp stands really for the person or the situation in which the shifting can occur. And then I write sharp Alice goes to person next to Alice, as opposed to Alice goes to person. So we start with Alice going to person, and it gets shifted to sharp Alice goes to person Alice, or it gets shifted to yourself cognizing Alice, yourself understanding Alice is pointing to that person who is Alice. So I take this to be a kind of description of what goes on when we do naming. And if you think about it, you will either agree or disagree with me, but you can look around and think about it, look at the objects in the room or the people in the room or anything, and understand that when you look at a cup, you know it's a cup. It's not a question for you. The name is with the object. And of course, sometimes you look at something and you have no idea what it's called or what it is, and it has a different flavor for you. It has that flavor of mystery or investigation. You would like to know what is that, And when you get an answer in the form of a name, you're partially satisfied. So this shifting is going on all the time. And the interesting thing is that it also gives rise to self-reference, this shifting. Here's how it gives rise to self-reference. Let's suppose that your name is Alvin. So Alvin points to you, but you then become acquainted with Alvin because you know your name is Alvin. So Alvin is with you, and Alvin is shifted to you, and then it's you with Alvin, which points to you as Alvin. Or me as Lou points to me as Lou. It's not that Lou in any abstract word sense points to me. It's that me with Lou points to me with Lou. In that modality, I refer to myself. And the syntax of that is there is a name pointing to sharp, the action of shifting. And if you shift that, then you get the combination of the shifting with M points to the shifting with M. And the shifting is what I'm saying. What I'm saying is more largely interpreted as the being of the person. But if you want to look at it from a syntactical point of view, it is an operator which does shifting. And when you look at it from the syntactical point of view, it shifts. It shifts from the world of understanding feeling in relation to thought and word into that other world of looking at formalisms. And indeed, and remarkably, when you shift this way of thinking about naming in that direction of formalism, it becomes the way Gödel achieved self-reference to prove his incompleteness theorem. I think this is quite interesting, and I'll show you what I mean. But before we do, here's a little review of what we just said. Before you have been fully introduced to the person, let's say it's Hein von Forster, they're being introduced to, you have this person and you're told it's Hein von Forster, but you shift it to the shifted Heinz von Forster name, the one that you've taken personally, and then when you see him, you know that he is Heinz von Forster. In the Goedelian situation, it's exactly the same, only you're talking about numbers. You aren't talking about people, unless you think that numbers are a kind of people. So you have a G, a number, which encodes a statement, S of U. S of U is some mathematical statement. It might be U is a prime number, right? And there is a number which encodes that statement by some method of encoding. Just like everything I write on my computer is encoded down into binary bits and sent around the world and over to you, an encodement. And so G is pointing to S, which talks about numbers. But since S talks about numbers, we can insert G into what it's talking about, and that shifts G over to the domain of S, just like Alice's name got shifted over to her. And then you have a new encodement, a new code number for that, and that's sharp G. So formally, it looks just like our indicative shift. G points to S, sharp G points to S with G attached. And then you can get self-reference just like we did by having a name for something that involves the shift. So there is some number that encodes S of sharp U. Sharp U is saying the encoding of, just as we did before, something that's been shifted. Or in other words, the simplest case is G is the name of shifting. But then when you insert G into that, you get that sharp G points to S of sharp G. In other words, S is talking about the number sharp G. But the number sharp G is the name of S. So S is talking about itself. So Gödel managed to obtain a kind of indirect self-reference in formal systems by using this trick. And this trick, which he invented, probably without thinking of it as having to do with the fundamentals of naming, makes his system work. You can get a sentence to talk about its own name. And because of that, you can get a sentence to talk about its own unprovability, because you start with somebody prior to shifting, which talks about unprovability, and then you shift it and it talks about its own unprovability. It says, I am unprovable. Literally, it says the statement whose code is sharp G is unprovable, but the code of that statement is sharp G itself. And so the Gödelian shift and the core of the incompleteness theorem that Gödel proved is based on the act of naming. So what happened here? Gödel proved that if you have a formal system, then it would be incomplete if it were consistent. And the way he shows it's incomplete is that by its very consistency, it couldn't prove a statement that says it's not provable. But we see from the outside that indeed, because it's consistent, that statement is not provable. And so we know that the statement is correct, that it's not provable. And so we can prove something that the system cannot prove, and thereby we conclude that the system is incomplete, and there are statements in it that cannot be proved by it that are nevertheless true. But the truth of that statement comes from our interaction as reasoners with the formal system. So that's a very strange thing, but it's also, if you think about the properties of naming, not such an unfamiliar thing after all. Because in order to have naming at all, the distinction between the name as a formal entity and the name as the name of someone involves crossing across the boundary between the distinction of someone and the more abstract domain of just names. And so the theme of the formalism and the cognizer, or the understander of the formalism, on both sides, the person named and the person who's naming, is occurring already back in the linguistics of naming. And it's been tamed in a certain way by Gödel in order to obtain this incompleteness theorem. But that incompleteness theorem is part and parcel of what happens when we separate ourselves from the world in a way that we really cannot do and form formalities. So let me see if there is in this slide something that I further want to say. Let me read it. So the statement, I am unprovable, which is what that little bit of formalism says the statement whose code is sharp G is unprovable, but that's its own code, asserts its own unprovability. And I don't want to read the rest of it because I have just said most of this, but the self-reference that arises from the indicative shift is not a trick. It's how we as beings coexist with our names. And it's a fundamental property of living language. And just so, in a certain sense, what Gödel did is not a trick, even though it is a trick. And the locus of meaning that arises in relation to my being and a given formal system is larger, even in the domain of reason, than that given system. The Goedelian argument is completed only by a combination of meaning and formality, the meaning residing on the part of the reasoner who's reasoning about the formal system. The statement that asserts its own unprovability is an amphibian between formality and meaning. The completion of the Gödelian incompleteness argument depends on the pivot between that statement, between formality and meaning. In order to be an inhabitant of the formal system, the statement must be a statement about numbers, and it is a statement about the number sharp G. But sharp G is the code number for a statement in the system. The Goedelian coding creates a double level for that statement, so it can consist as a statement about numbers and as a statement about its own structure. It's this double coding that allows us to make our interpretation of the meaning of it and to conclude the truth of that meaning on the basis of the consistency. The meaning and the truth of the statement arises in the loop of interaction of the interpretant or observer of the system and the structure of the system itself. Prior to Gödel, people hoped that truth would just be the same as provability. Here, a truth arises in relation to provability, but the provability is the provability that comes about by the reasoner reasoning about the formal system. And so it comes about through reasoning that goes outside what the formal system can do itself. Leibniz said that the square root of negative unity is an amphibian between being and non-being. When non-being is taken as formality, we see that the Goedelian statement is an amphibian between the being and the formal. It's not that meaning or being arises from non-being, but rather that they arise together. In the Goedelian formalism, meaning and being come together in the constraint of the coding and its possible interpretations. The entity, the Goedelian sentence, is a pivot between meaning and formalism, between being and non-being. And if you're thinking along these lines, then you can find, I believe, that it helps in thinking about what it might mean for machines to be conscious or not. And I'm not taking sides on that issue, but what we see as being related to being and consciousness has to do with these loops of interaction that go between something which is regarded as purely formal and something which is involved in an interaction or a reasoning interaction or a search for meaning. And when you have both sides of that interacting, when you see that those two sides are coming from something larger, then you tend to think or use the words consciousness. And when you only have one end of it, like the purely formal end of a text with no reader, then you tend to say absence of consciousness. So what needs to be attended to is the meaning, is though that interaction between the formal and the non-formal. And I think that these topological games that I've been playing are helpful in letting a person move back and forth between the formal and the informal, and to see what that means for all of these larger questions. Now, I included in my slideshow some puzzles here, and I think that we've spent quite a bit of time already here, so maybe I will show you a little of this and then we'll stop. So one puzzle is this puzzle, very nice one. It's a sequence of numbers. You may have seen it before, 1, 11, 21, 1,211, and so on. And the question is, what's the next number? If you've seen it, you know that there's a very nice interpretation that allows you to see this, but it's not an obvious interpretation. The interpretation is that you should read it out loud, and then you will see. If I read it out loud, I get 1. then I get 1, 1. But 1, 1 describes 1, and then I read 2 1s, and that describes the second one. And 1, 2, 1, 1 describes 2, 1. And 1, 1, 1, 2, 2 1s describes 1, 2, 1, 1. And 3 1s, 2 2s, 1 1 describes 1, 1, 1, 2, 2, 1. And so 1, 3, 1, 1, 2 2s, 2 1s describes the next one, and we see how to build it. Each one is describing the one before by reading it out loud. So we're describing, and out of describing in this recursion comes this a very complex structure. And you could start with something that isn't a number, like a star, and then you would go 1 star, and then we would go 1 1 1 star, and then you go 3 1s 1 star, and so on. And if you let the star be 3, then it's particularly nice. I don't know if I illustrated that. If you had a 3, then you would say 3 1 3 1 1 1 3 3 1 1 3. And if you look down here, you'll see 3 1 1 3, and then it extends on out. So that if you started by describing 3, every sequence down 3 will extend what you had before exactly. And then you can wrap them all around one another like this and obtain 3 infinite sequences such that A describes C, and C describes B, and B describes A. You see, B describes A, 3 1s, 1, 3 1s, 1, 3, and so on. And C describes B, 1, 3, 2 1s. And A, 1, 1, 1, 3, describes C. So it wraps around itself like that. Not obvious that you could have obtained that. It's like the topological situation of 3 rings that hold each other up. If you remove any one of the rings, they fall apart. And the simplest thing you can say about this example that I'm giving you is that 2, 2 is self-referential. 2 2s describes itself. In the eerie center of all of this complexity is the little sequence 2 2, which is self-referential. This is a diagrammatic example of thinking about the Russell paradox. The Russell paradox says X is a member of R means that it's not the case that X is a member of X. I've written it in a highly condensed form on the top of this slide. And then when you ask about R, you get R is a member of R exactly when it's not the case that R is a member of R, which looks like a paragraph, which looks like a paradox. But if I think topologically, I could say that a little twist in a rope is like A belongs to A. And if I remove the twist, that's like A is not given to belong to A. And adding or subtracting a little twist in a rope is innocuous. So, of course, that isn't the solution to the Russell paradox because it was supposed to be solved on its own grounds, not on the grounds of an analogy with a picture. But on the other hand, you can ask how those pictures might represent sets, and then you can see some evidence for thinking about reflexive set theory in a certain mode. I'll show you what I mean for a moment. I can have a line going underneath another line and say, the line that goes underneath will be a member of the line that goes above. And then you could have somebody which is belonging to itself because it curls underneath itself like that. And you could have A as a member of B and B is a member of A, and that's a weaving between two. So you see that in the topology, the weaving is mutuality, the self-reference is twisting, and suddenly the knots can be viewed as a domain of language that is self-referential in a way that might seem a little surprising and not so surprising if you think back to all the patterns of weaving that go back in time and design. And some of it illustrates straightforward things about counting. Here is the empty set, nothing goes underneath it. Here, the set labeled 1 has one thing going underneath it. The set labeled 2 then has two things going underneath it, 1 and 0. And the set 3 has three things going underneath it, 0, 1, and 2. So this is a way of generating numbers. Each set is the set of all the previous numbers. It's a weaving that it has no under and over in it. It's all just quite layered. Enough about that, I think, but you get the idea. So I could go on with more topological examples, but let's just summarize, and perhaps there will be some discussion about these things. The slideshow has been just an introduction to some mathematical and conceptual points of view about reflexivity and naming, and how these principles work in the world a little bit, and the way the structures come and go. And beneath the remarkable and unpredictable structures that arise from such interplay is a lambent simplicity to which we may return as to the source of a world. I'll stop there.
Thank
Okay.
you very much. Excellent. Very
Much
interesting.
Okay, so thanks a lot. So who wants to start with questions?
Well, I mean, if somebody needs to start, I could. Luis, I've been one of the last students of Francisco Varela. Unfortunately, he died at the end of my first year of PhD. So I'm familiar somehow with, of course, everything you talked about. And I tried to read his Principle of Biological Autonomy, written in 1979, I believe, or something like that, in which there is a fairly long chapter about Spencer-Brown algebra, or arithmetic, I don't remember, formalism. And I could never really put my mind through it beyond a couple of pages. I've never been able to really get the logic of it. Maybe you could, I don't know if it's possible, but give us a bit of more about it to understand how it works.
Sure. The first thing and the last thing I would ever say about that is that what's being talked about in Spencer Brown is the idea of a distinction. And one should look at that before starting in on formalisms for self-reference and all of that. But maybe we could look at it. Let me go back to my share here.
Yes, please.
And scribble on a board a little bit. There. So if you began by saying, I'm just going to think about some simple distinction, like between the inside of this curve and the outside of this curve, then then you would be likely to say, all right, then I should have a transformation which takes me from the inside to the outside. And let me use Spencer Brown's symbol for that transformation. And the transformation is to cross the boundary. So either crossing from the outside to the inside or from the inside to the outside will denote crossing the boundary. So then I would write crossing from the inside gives me the outside, and crossing from the outside will give me the inside. And that doesn't seem to be problematical, right?
Yes, correct. Very clear. Up to that point.
That's simple enough.
Yeah.
But then you could further say, let's not use a mark for the inside. For simplicity's sake. For the sake of simplicity, let's not use a mark for the inside. And if you did that, then this looks a little strange for a moment. You would have the outside, and you would cross from the outside into the unmarked. Or you would cross from the unmarked into the outside, right? So that would be written as crossing from the outside, you arrive at the unmarked. Or crossing from the unmarked, you arrive at the outside. So
Yeah.
I submit that Spencer Brown had some thoughts like that because he had some practical reasons for making a formalism that he was working with as simple as he could, right? So why have an extra symbol, right? But then this suggests something further. This suggests that we could eliminate the O and just use the mark. And then it would read, crossing from the mark is nothing, and the mark is just equal to the mark, right? Which is not really needed to say anything. So, in other words, our picture has now condensed a little further to the mark is the name of the outside, but the mark is also the name of the transformation, which takes you to the unmarked state. And when you do the transformation in the other direction, you get the name of the outside. And curiously enough, beautifully enough, this all works because, well, I'll put it up here, because this is equal to a mark, indeed, but it's also equal to the instruction cross from the unmarked state. The unmarked state is indicated iconically by nothing. It's unindicated. So if you cross from the marked state, you're unmarked. If you cross from the unmarked state, you're marked. And you see, in that case, perhaps we should have these as two equations, right? It looks like mark equals mark is just not saying anything, but it is saying something because here I think of mark as a verb and here it's a noun. So cross from the unmarked state is the marked state. But of course, I could read it the other way. Cross from the unmarked state is the marked state. But here there's a something, and crossing from that something gives me the unmarked state. So we arrive at Spencer-Brown's equation, mark over mark equals nothing. And the other equation, that 2 marks is equal to 1 mark, is a way of saying that if you, well, Spencer-Brown says this is calling the name twice is the same as calling it once. But the name that's being called is the name of the outside. The name of the outside is marked. And if you went one step further in my descent here, it would look like this. Allow me to go one step further by condensing my descent right there, and then taking out this part. And now I can descend one step further like this and get down to one symbol altogether. I'll use for my distinction the mark itself. We distinguish between the inside and the outside of the mark. So there's my distinction. Then the mark stands for the side that's the outside, and crossing the boundary takes you to the unmarked state, and crossing the boundary this way takes you to the marked state. But then you see that it's quite redundant. Why do you need another mark labeling this mark? You don't really need it. It's just this, because the outside is marked and you don't have to put a label on it. This is like a man wearing or a woman wearing a name tag, and the name tag is superfluous. So this is superfluous name tag, except that at this level, the entity and its name tag are indistinguishable from one another. So you can remove one name tag and it's all right. It's a little like, and if you went in this direction, it's a little like mitosis. So if you think this is a living entity and not a name tag, well then in this direction, it looks like mitosis, from one living entity to living entities. In any case, that's my story about some of the meanings that are associated with these two equations.
That's very helpful. Thank you very much. I don't know if you remember, but in a principle of biological autonomy, maybe I'm mistaken, but I seem to remember that Francisco introduced a modified version of the mark that is supposed to be a mark for self-reference.
Yes, let's talk about that, all right?
Yes.
But let's talk about this for a moment first, so we're clear about what goes on now. At this point, at this point, we have entered into something mathematical. So let's take it slow. Prior,
thank you.
If I just said we had this, then we could be quite semiotic about it. We could say, well, this is a mark. It stands for a distinction. It stands for any distinction at all. I don't have a calculus here. I just have a symbol which stands for any distinction, like many other symbols in the world, like the cross stands for a religion, and the Mogen David stands for a religion, and this stands for an idea, the idea of a distinction, or it could be regarded as a distinction. But once we decided that there were certain equivalences, such as a mark over a mark is unmarked, and a mark next to a mark could be replaced by a mark, then we've entered into calculation. And so we've entered into a mathematical domain where the usual kinds of things that happen in mathematics will happen. For example, I could consider various expressions like this. And an expression is a collection of marks so that of any given mark, you can say whether or not it's inside or outside of any other mark. This mark is outside of these two, it's inside that one, outside this one, and so on, right? And then you can apply these elements of calculation. You could remove those two. And having removed these two, I now have one of these, and I can remove it, and I end up marked. Right?
Yep, very clear.
And and on the other hand, I could make it more complicated. I could say, well, I think I like to make it bigger. And that's also true. I just did some of these moves and made it bigger. You end up with a theorem. The first theorem is that every expression can be simplified to mark or nothing, and the simplification is unique. That you will never end up simplifying it to a mark and also simplifying it to an unmarked. So each expression uniquely stands for either a marked state or an unmarked state. And then you begin to get other mathematical things that you can do. You could say, I will think of any A, marked or unmarked, and I could do this. So this becomes a kind of negation. Right? That is to say, if you apply it to a mark, you get an unmarked state. And if you apply it to the unmarked state, then you get a marked state. I've used a name for the unmarked state. Right? So this is like the negation of true is false, and the negation of false is true. So you're beginning to get something that's beginning to look like logic and algebra. And you can do other things. You could consider AB. Yeah, and how will that behave? Depends on what A and B are. Or you could consider, among other things, you could consider AA cross. That's a nice one to think about. What kind of values will that have? Let's try it out. If I put A equal to the unmarked state, then we will have just a mark. So it's marked if A is unmarked. And if A is marked, then we will have mark, cross, but that goes away and it's marked. So this tells you that A cross is equal to the marked state for any A. And so on, and you can do algebra, and you find out that you get a way of representing logic, and you can represent Boolean algebra. And though all those things are coming out of this consideration of making a distinction and all of that. But the key epistemological thing is that the mark itself is both a name and a transformation, right? It's both a noun and a verb. Transformation. That's rather different from what happens in logic, where you have certain transformations like negation, and you have values like true and false, and they're separate. But here, the mark is a value, and it's also a transformation. So what you started with here is a reflexive domain of a certain kind, simpler than the reflexive domain that I was axiomatizing, maybe. But it is true, it's reflexive. The mark is a transformation, and it's an object. Now, it also is self-referential. I have to emphasize that before I start talking about what Francisco did. The mark is itself self-referential. Because it refers to any distinction. Just as the number two, I'll just write, oh, I'm misspelling, but refers to any distinction, right? The number two is a fundamental mathematical entity, and it refers to any couple, any pair. The mark refers to any distinction. It's a wider mathematical reference than a number. Refers to any distinction, and it refers to itself because it itself is seen to be a distinction. So already you
may I ask something while you are just here? So does that mean that somewhat that connect to impredicative concept formation? The fact that
you want to tell me what you mean when you're asking the question? I'm not sure how you're using the word impredicative, so go ahead and say a little more about what you mean.
I'm going to try, but I don't want to interrupt the flows because we have worked with Kenneth Williford for many years with a colleague and friend named Gregory Landini. He is a logician, and he has tried to convince us that actually impredicative concept formation is the key to understand.
Well, do you mean defining things in terms of a proposition? Is that what you mean by impredicative?
Yes, but the propositions that require, I mean, basically you have so let's start from a set. You want to
well, let me
define
write something.
A property.
Wait. Maybe if I ask you a question, we can clarify.
Yeah.
In set theory, I like to form a set like this. I say the set of X such that X is a prime number, right? I do this all the time, right? That's not my sharp from before, it just means number. X is a prime number. That's a statement, P of X. So this is the set of X such that some statement, P of X. And so we often think of bringing things into existence in mathematics by making a set, by taking a proposition, which could be either true or false, and then we look at all the things where it's true, and that gives us a set. It also gives us paradoxes if we're not careful, so we have to put some reins on what we are allowed to put in here. But in general, when we're making mathematical constructions, we do it by writing down a predicate like that. Is that what you meant by?
Yeah, I'm going to give you. I'm going to give you an example. For instance, a set that would be. It's a bit trivial, but non-problematically.
Let's get a clear board.
Yeah.
All right.
Defined impredicatively would be, for instance, the smallest or the shortest man in the room. So that's a set you need in order to identify the property. Here, it's actually an object, an element of the set, but it could be a set of properties. But let's have this simple example.
We could say we could define someone by saying he will be the shortest, in which case it might be unique, or there might be some runner-ups, right? There might be hard to tell who's the shortest, so there could be more than one, right?
Yeah, the deal is that you have to quantify over the entire set in order to identify, in that case, the element that satisfies the property.
Yeah.
The smallest person, the shortest or smallest.
Right, and some ways there are some paradoxes that can be easily created
Yes.
by doing this sort of thing.
Yes.
Like the least number, the least integer, the least positive integer that can be described in no less than 100 words. Right.
Yes.
Berry's paradox, right? And so on, right?
Yeah. So just to finish and connect to what you said before and why I thought about this impredicative concept formation. Just first of all, here we took a very trivial example with the shortest man in the room, but now you can define a property that requires to quantify over a set, for instance, the property that is an intersection of all the properties in a set. So you always have a larger set, and in order to define the property somewhat, you have to accept that the very property that you are defining is in the set. So that's why I thought about that, because when you say it for the mark, that somehow it's a mark that represents the sets, to use the analogy with sets, the sets of all possible distinctions,
right? But remember the mark
itself.
When I say the mark refers to any distinction, I'm working in ordinary language. I'm not working in set theory.
Right? Yeah, I know. It's an analogy.
It's an error of reference. And I'm saying the mark refers to any distinction, and therefore the mark refers to itself.
Yes.
Refers. But this is not part of the calculus that we're working with.
Yes.
This is not part of the calculus of indications, the thing that is defined by these equations, right? Etc. Okay. It's now the kind of self-referential entity that Francisco wanted to introduce. He wanted it to be part of a calculus.
Correct.
That's the first thing as we get to it. But why does he introduce this? First of all, it has to do with thinking about recursion. So let's think about it outside of this calculus first. One can imagine, well, I'll call it J. We can imagine J, which is an infinite nest of marks like this, right? And now you can no longer simplify. Can't simplify. In a finite number of steps. By that calculus, right? Because even if you use A double cross equals A, right? Which you could do, you could be allowed to do A double cross equals A after a while, even though it's not part of the calculus, because you can check that this will evaluate correctly, right? A double cross equals A is an identity like the one I told you. So it comes out of our mathematics after a while, right? We have, if A is unmarked, then we get unmarked, and that's unmarked to unmarked. And if you had a mark, then this cancels and you get a mark. So if you double cross a mark, you get a mark. And if you double cross nothing, you get nothing, right? So A double cross equals A in all cases. So we could say, all right, then I can knock off 2 of these. And then I'll knock off 2 of these, but there are infinitely many, so it'll never happen. I can't, in a finite number of steps, make J disappear, right?
Right.
And on the other hand, J is apparently equal to a mark over J. It re-enters its own indicational space because, well, I could just draw you I mean, you know, that's by its definition, it's not different, right? It goes on forever, and you can add one more. So J is equal to J cross. And so you might write, as Francisco liked to write, J equal to somebody that goes inside itself like that, right?
Yes.
But then the question is, can we include J in the calculus? It's asked to be a value calculus. It would be a value that's not marked, and it would be a value that's not unmarked, right? It'd be a third value. And it would be like a multiple valued logic, but also it would be a symbol for it would be a symbol for a recursive entity or an autonomous entity because he's thinking biologically. So it's a recursive entity or a biological entity, an entity that is self-referential, biological, recursive or biological or autonomous, producing itself from itself. You can think of it as producing itself from itself, right? It has the property that it is invariant under crossing. It goes into itself, all that, right? So he had the very nice idea of putting it into the calculus right at the beginning. Why not do that? Yeah. But if you do that, and you keep the and you want to keep the calculus in the usual way, you run into a problem. And the problem is the following. Consider. We're going to have the re-entering mark, and it's going to be invariant under crossing. And presumably, if you put it next to itself like this, just like anybody else, it should be equal to itself. We want to keep the rules. One of the rules is AA equals A. Another of the rules is AA cross is equal to mark, right? As I was showing you. And other rules, right? A double cross equals A. That's innocuous. But there are various rules. We'd like to keep those rules, all the rules that we know. Another rule that we would like is that if you put a mark next to A, it should be equal to the marked state. Notice that that's true for marked and unmarked, right? If you put a mark next to this, then that's just one mark, so that's okay. And if you put nothing next to it, you get a mark. So no matter what you put next to the mark, you get the mark. So mark next to A is marked. There are various rules. We'd like to keep them. So we could put them into the arithmetic to begin with, like that. Okay, that's probably it. And then we would have the usual rules like this. And that looks like that would be a nice arithmetic to have, right? Where we include an autonomous element, a kind of special recursive distinction in at the beginning, self-reference right in the beginning, like that. But then you start calculating with it a little and you say, let's see. We would like the mark to be equal to this next to this, right? That's this. But this is equal to this. And this condenses to that. So that says that our autonomous element is the mark.
Correct.
And then we could, so that says the autonomous element is the mark. And then if we cross that, we would get that the unmarked state is equal to the cross of the autonomous element, which is also equal to the autonomous element. And so that together tells us that the unmarked state is equal to the marked state. And now we're very sad because the whole thing is collapsed.
Do you remember what did Francisco realize that in his?
Oh, of course, he
chapter?
understood this. And so Francisco said, okay, we need new rules. And Francisco said, okay, we will remove this rule. We won't assume this rule. Because it shouldn't be true, right? It isn't true. We want that we, as part of our assumption that this is not equal to this. So therefore, what we just showed was that this rule doesn't work. So we'll remove it. This is called remove the law of the excluded middle. Law of the excluded middle, which is a move that logicians have used to get multiple valued logics, and he uses it here. And you get a different algebra. You get a different algebra, a different new algebra describing this arithmetic. Which he called the calculus for self-reference in his paper. And that turns out to correspond to Lukasiewicz three-valued logic. And that's one way to get out of the difficulty. One way to get out of the difficulty is to say, we will remove this rule. And then if you wanted to go more deeply, we would have to say, well, exactly which rules are we keeping and which ones are we removing? And I haven't memorized them for this, so I'd have to look up my paper or his paper. There are different choices, and you can have some fun with that. But there are other ways to think about this as well, but this is what he did.
Well, thank you so much. Very selfishly, really.
Yeah, no,
I never was introduced to it in such a clear
so
way.
I hope that gives you some introduction to that.
Oh yes, yes, really opened the lock in my mind.
Let me show you another way out, okay? Another way out, okay? And this way out is actually kind of close to what Spencer Brown had in mind, I believe. But it's a little different, and we call this the flag resolution because the idea comes from Jim Flagg. The flag resolution is the following. In a formula, if you change any autonomous mark to its cross, you must do this to all autonomous marks in the formula. Now, you need to see the consequence of that. So let me just copy that statement and show you what happens on the next slide. Oop. All right, there's my statement, and we might clean it up a little bit just so if you looked at it again later, it wouldn't look so messy. All right. So let's consider this. We were getting a paradox out of we were getting a paradox out of this, right? But no longer, because if I want to collapse this, we do have individually we can say this, right? But if I have this next to a mark, I have to maintain, I'm going to have to do it to both of them. So if I'm going to replace one of these marks by this, like that, then I have to do it to the other one. So I can state that these are equal. That's allowed. And this reduces by the usual rules. We'll still have all the usual rules. We won't relinquish any of our usual rules. We have that. So all I did was permute them. And among our rules is that AB is equal to BA. That's one of the things that comes out of these. So this is just a rewriting to that. And I'm just spinning my wheels. I'm not getting any problem at all. No problem. No paradox arises. So I can keep all the original rules, but use the flag resolution. Now, I happen to think that's a good solution, but it isn't a very well-known solution, flag resolution. And it's not, you can think about using that kind of resolution to handle Russell paradox and other paradoxes as well. There's a reason why this is a good idea, in my opinion, because you can think of the reentering mark temporally. If you think of the reentering mark temporally, then it becomes something like this. Marked, and then you cross it, and it becomes unmarked, and then you cross it, and it becomes marked, and then it becomes unmarked, and then it becomes marked, and then it becomes unmarked, and this goes on like that forever in both directions, like that. So you can think of the reentering mark as a kind of square wave. Marked, unmarked, marked, unmarked, marked, unmarked, marked, unmarked, like that. Right? That would be the reentering mark. And if you crossed it as a temporal entity, then that means that at this time it's now unmarked, but at this time it's marked. And so it's the opposite square wave. So you see what I mean? When it's up, it's down. When it's down, it's up.
Yep, yep, yep.
At any given time. And then when you combine them together temporally, it's always marked. Always marked. So if you think of it temporally, then you've shifted one from the other by making it marked. One is marked when the other is unmarked, vice versa. And the whole thing should be marked. And when you are going to replace one of those by the cross of it, you really should replace both of them so that they maintain their synchrony.
Interesting. And did Francisco think about it, could consider it that way? Because as you know, he was...
No, I don't think he did. And he and I came close to thinking about it this way when we wrote the paper Form Dynamics, which was all about thinking about these things temporally in this form.
Yeah.
But I think that we didn't think about the flag resolution until a little later. And maybe by that time he was in France and I was in Chicago, and I don't think we ever had a conversation about the flag resolution. It would have been very interesting to do so because it's very close to the attitude that we had when we wrote our paper.
Amazing. Very interesting.
There are many different points of view. It depends on what you want when you try to get paradoxes to stop being paradoxes, right? Most mathematicians want to have their sets independent of time. And that leads to the usual restrictions on predicative definitions that we know about for set theory and so on.
I see. Well, thank you very much. Maybe other people have questions since we have you, and it's a really great chance to have you. Ken? Or...
Yeah, I have just a follow-up about the temporal interpretation there. I seem to remember a paper by someone named Andreas Kuhl that relates that to the liar paradox. So
could be. I don't know if I've seen that paper.
Okay, so it's just wondering sort of where the
how do you spell his last name?
I think it's Kull.
Sounds familiar, but I don't know. Let
I
me make a
remember
note of it. Andreas
Kuhl, yeah. Kuhl, I don't know. Yeah.
Certainly many people, even Russell probably, I believe, wrote about thinking of these paradoxes temporally. So some people think of the law, and that's Spencer Brown also. Spencer Brown says, well, you can think of that paradoxical element as a temporal element, and you can think of all of these recursive things as things that happen in time. But then with Spencer Brown, it becomes subtle in another direction because Spencer Brown was designing circuits that behave in time. Circuits like the circuits at the bottom of your computer that work by having signals go into them, and there's no clock, but because of the structure of the circuit itself, it will behave in a certain determined way, independent of the time delays that are involved in the elements in the circuit. And so he was thinking of asynchronous design when he's thinking of interpreting things temporally. And you can see that if you look at chapter 11 in Laws of Form. And asynchronous design is very beautiful and interesting, and many subtleties involved in it. And I think that in a way, it speaks to questions about what is the nature of time itself. Because if you're thinking in terms of asynchronous design, you don't have time to begin with, but you have structure which gives rise to certain kinds of sequential actions that are allowed. And then you realize that entities which can behave sequentially according to that, then become temporal entities.
Mhm. Yeah, that's very cool. I wanted to ask you about non-well-founded set theory because it struck me I was looking at some of your papers. I was writing another paper and I thought, you know what? A lot of the diagrams, because I've spent a lot of time thinking about non-well-founded set theory, and a lot of the diagram, just struck me that a lot of the diagrams in your papers, they look like that. So I just wondered if you
Uh-huh.
thought about,
Let's talk about translating one into the other and
yeah,
back.
that's what I wondered. Yeah.
Of course, the equivalence relations that are used in what's his name? I forgot.
Like Peter Axel or
Axel's
yeah.
set theory. He uses certain kinds of equivalence relations on his sets. That will be different from what I'm doing, but Axel says, okay, I will represent a set by a node in a graph. And I will say that another set is an element of it if there's an arrow which goes from one to the other. I may be misrepresenting him, but let's suppose that we use that, right? So then we have A belongs to B, like that, right? It's node and another node, and that means that one is an element of the other. And then you can have mutuality in this form by this. Then you would have you would have A as a member of B, and you would have B as a member of A, or you could have A as a member of A. So what that means is that that you have a directed graph, and graphs with loops correspond to non-well-founded sets. So that's the diagrammatic. And so if I have an edge and I have another edge going underneath it, and I have this edge is labeled B and this edge is labeled A, then the underneath can be thought of as an arrow, and you have an A, and you have a B, and you have an arrow which goes from the A to the B, like that. And so you can translate back and forth between what I draw as an unwell-founded set and what he draws. So here, for example, there is one node, that arc, and one arrow right there, right? And that is the self-membership of that guy. Some features in what I'm doing are not happening here. They're to remind me that I'm thinking topologically. So for example, I have this, I have an A and I have a B, and then I have A is equal to B inside of A twice, right? And something else may be happening. And I would like this to be equivalent to, because I want to have topological relations, A is equal to nothing at all and whatever else goes on, and they get pulled apart. So even numbers of occurrences of one in another will cancel out, and so on. There are differences in the rules. But does that help in terms of the diagrammatic translation?
Yeah, definitely. Yeah, it's very clear. May I ask a follow-up question about this?
Sure.
So if you and this is a more let me think about how to phrase it. I mean, if you wanted to, well, let me think for a second where to start. So I'm sure you know in non-well-founded set theory, you can't rely on the axiom of extensionality to distinguish sets anymore. So if you want to just distinguish sets in terms of their members and say you have a set A, which is contains itself and some object, whatever, Zermelo, and you've got B, which contains itself and Zermelo, and then you try to apply the axiom of extensionality to determine if A is identical to B. You can't. It turns out, yeah, A is identical to B if A is identical to B, but you can't answer it because you can't just reduce the set to its objects other than itself. So there are different ways of trying to deal with that problem. So Axel's way is to just relate it to graphs, basically. The anti-foundation axiom. So I always thought that it's kind of an interesting feature, this idea of self-inclusion or self-membership as a kind of it looks like you're dealing with something irreducible. So it's a bit like your autonomous, what you indicate with the
Yeah, it is, right? I mean,
like so you
if you
you
think
can't
of
build it up.
that guy is very much like this guy. Yeah.
Yeah, like the self-singleton, right? Yeah.
Mhm.
So you of course you can represent it as big as you want, contains itself as many times as you like. But my thought was if you thought that consciousness has a structure like this, but you also think that consciousness is in some sense reducible or could be realized in something physical by some kind of step-by-step process, maybe like building some structure that becomes self-supporting after you take the scaffolding away or something like that, like an arch or something. So my thought is when you're dealing with entities like this and you want to come up with some physical interpretation of them, do you have any ideas about how to go about that? Or do you just say, no, if you thought that consciousness has this kind of structure, you're just committed to it being irreducible and inexplicable in any kind of physical terms.
And I should add, Ken, you want to mean it by excluding the possibility that we resolve the problem by adding a temporal structure, correct?
Yeah, I'm putting the temporal thing aside. Yeah. So not just so yes, right. I am thinking about it as synchronic in a way. Like how do you realize this in a
Well, that's where I would like to play with those analogies with topology to see whether they will help us. I'm just creating a blank backboard for a moment. Consider the fact that I indeed can analyze these highly circular kinds of structures up to an equivalence relation, like this knot, right? I have this gadget, and I have and they're graphs, like well-founded set, like the non-well-founded set theory. These are graphs, and they have a lot of circularity in them. And then there are certain rules that I happen to be fond of for dealing with them because they correspond to what I can do topologically. I can untwist something. If the rope goes under itself twice, I can pull it apart. If I have crossing underneath this on the upper side of that, why then I can take the rope and slide it down and cross it underneath below. And you think I'm going to go on and list more rules, but I'm not. Those are the rules. Those turn out to be the generating rules for doing topology with these graphs. So I have a very interesting game that I've been working with for a long time of trying to understand when is one thing like this equivalent or not equivalent to another thing like this, like these two, by using these rules, right? So, so you have some highly circularly interconnected thing, which is subject to some rules of change, and how do you know whether or not you can transform it to another? And you end up using circularly defined sets of equations in order to do that. You might write something like this. You might label the arcs. I don't mean to teach you technicalities. I'm just showing you what might come out. You might label the arcs like this, and you might say that if this arc goes in and that arc is here, then this one will be the product of these two in some form of algebra. And then you would have C is equal to A times B. I'm sorry. C is equal to A times B, right? And B is equal to A times C. And C and A is equal to B times C. That isn't the one I wanted. A is equal to C times B, right? But, one equation from each one of these interactions here. And then you have a circularly interconnected set of equations, like like the reentering mark, right? These all are interrelated to one another, but nevertheless, under some circumstances, you can tell something about this structure in terms of this circularly interconnected structure. You can do algebra, you can do mathematics with these things, and study them, even though they're circularly interconnected. This does not address the problem of consciousness. It just points out that things like well-founded sets, which is what the non-well-founded sets, which is what these topological entities are rather like, can be handled mathematically, and one can get a lot of information about them. Now, when you try to think about consciousness, what question are you asking?
Okay. So are you sort of asking what how do I see
So
this?
I'm backing up. All I remarked was that at the level of circularly interconnected things, like non-well-founded sets, things with some kind of turnaround built into them. Well, topology is in fact a subject which deals with such things all the time. That's all I'm saying. And you really can't, you can use modern algebra, you can use many techniques to get information, because you're asking about kind of an architecture and how it will behave under certain kinds of transformations.
Mm-hmm.
But if I were trying to understand consciousness, I'm not sure that this is addressing the right question. It might be addressing the question, what sustains consciousness? I know that I go along during the day and I'm conscious a lot of the time, or a little part of the time, but certain things leave me in an automatic mode. And I do a lot of things in an entirely automatic mode, right? And then I'm sleeping and so on. So where does consciousness have its own autonomy, and how does it persist? But it's hard to understand what mathematical structure I should be reflecting it into.
Gotcha. So I can just tell you sort of where I am coming from on this question. I mean, so the view is something, or the approach is something like, let's take the phenomenology of consciousness seriously. What are its basic features, that are maintained throughout its variations? There's a long tradition of thinking that one of those features is a kind of self-consciousness, that it's a kind of pre-reflective self-consciousness. And where that's
so you might say consciousness equals consciousness. There is some kind of self-reference going on.
Exactly. Yeah. And then the issue is, okay, how to think about it. So there are various views. Some kind of explain it away as just kind of an illusion, or it's an ersatz thing. But if you take it really seriously, as I tend to do, you are kind of led in the direction of thinking it's a non-well-founded structure of some sort.
Right.
And there are different, tools to think about that kind of thing, metamathematics, non-well-founded set theory, of course, and I kind of, that's the one I'm sort of most partial to. And then if you think, though, something like this, look, in the case of consciousness, how it appears is how it really is. So it's really a non-well-founded thing, if you like. It's really it's a real structure in the world, real entity in the world, if you like, that has this kind of structure. And then if you add to that, and I also want to think that it's some kind of brain process, or it's at least realized in brain processes, then you're led to the question, okay, how do you realize non-well-founded structures in brain processes? So that's kind of the question I'm asking. And there's one sort of tradition of thinking about consciousness that accepts this non-well-foundedness, that says it's basically irreducible. Just forget about ever relating it to some kind of physical realization. Precisely because of its, they don't like to accept the circularity here, but for them, they're kind of caught between just Mysterianism and circularity. So I kind of think what they really are saying is, well, it's circular like this, but you can't decompose this kind of circularity, just like you can't get the identity of a non-well-founded set just by looking at its elements. You have to have some other way of fixing its identity. You can't just compose it up out of elements the way you can in sets in the cumulative hierarchy, you know? So that's what leads to the question. You take the phenomenology seriously, it has this kind of non-well-founded appearance. That's not an illusion, so it really is that way. And then if you also say, and I would like to think that it's some kind of brain process, something realized in real physical brains, then the question becomes how to realize in physical brains non-well-founded structures. That's the kind of line of thought here. Does that?
And if possible, if I may add something. Yeah.
I'm sorry, go ahead.
And if possible, because that's the thing we've been working on, if you can add another constraint as a second part, that the phenomenology of this so-called non-well-founded structure has somewhat to be embodied, I mean, manifested as some sort of spatial or some sort of experience of space. So that's to connect with your note and topology. But that's a secondary set of issues. There is the first question.
Are you talking about the consciousness itself should be, consciousness has experience, right? Mm-hmm. And you're saying the conscious experience is, I think you're saying this, conscious experience is spatial, whatever that means.
Part of it, at least, yeah.
Somehow we feel that way, right?
Yeah.
What it means probably is close to what we mean in topology by topological, I think. I mean, the spatial experience is having some notions of relationship, that some things are near, some things are far, there is a sense of containment, and so on.
Correct. But in a manner that somehow manifests itself in a kind of, by analogy, like your first bullet point, circular or non-well-founded manner. Basically, it's a space in which it's...
Well, the circularity is related to what he said earlier, that,
right.
That how consciousness appears is how it is.
Mm-hmm.
I mean, I don't doubt it, right? Here I am conscious, and this is my conscious experience, and I'm conscious of our consciousness as well, however we think of that, and all of that is part of our experience, our conscious experience.
Mm-hmm.
So there's this inability to separate it out and make it objective in ways that we can do in other cases.
Yeah, kind of. Yeah, I think so.
But that's the part that's very difficult to capture in any mathematical model, because you're used to building your mathematical models so that they're over here. This this graph is over here, I'm over here. It's always seems to be that way. I may take on some geometric demonstration and use my arms and body, but it's almost always, once it's formulated, it seems I can separate it. But when I separate it, it's incomplete.
Correct.
There's my world of conscious reasoning, which I don't know how to apply Gödel's theorem to it. But if I over here have a nice set of rules all laid out as a formal system, then I can apply Gödel's theorem to it.
So yeah, I don't know if Ken, you want to continue on the point that you were asking, or
so the
well,
question you're asking is, could we model consciousness?
well, my question maybe we could take it in a more general way. Do you have some ideas about physically realizing non-well-founded structures? Or is it like they kind of, so we have our experience, we don't know how to think of that in sort of physical terms, suppose. Um, and non-well-founded sets are kind of a metaphor for it, but they're kind of abstract entities that we can't really think of as concrete.
Well, yeah, I mean, but I think of a knot in a rope as a physically realized non-well-founded structure.
Okay, yeah. Yeah.
But I think you exactly, Luis, got, I mean, working your mind, get the type of problem we are after. And then, of course, you have, because you have been thinking about those things, including with Francisco for so many years. So we kind of come back, you know, to things that have been debated, thought very deeply. Unfortunately, this is not what dominates the field of the so-called consciousness studies. But here, the group that you have here, we tend to believe that it's actually essential to tackle the problem of consciousness, so to speak, both in its phenomenology and its in realization, if you wish. That's the type of 4 bullet points that you wrote on the bottom right is exactly this, what we need to tackle. How that's relate to each other.
Yeah. So,
oh,
can I just say one last thing? You had, at some point, you had a picture of 3 rings that, you know, if you take any one ring out, the whole structure falls apart.
Yes.
Yeah. So I was wondering, I mean, so in a way, that's a kind of non-well-founded structure, because the
That's
one
the
ring,
Borromean node.
yeah, but yes, the one holds the other 2 together. Like that's the same for every one.
That's right. That's right.
But to build it, you kind of have to have you're the scaffolding for it. You're from the outside putting the whole thing together, and once it's together, or you're the one chiseling it out of a block of marble, you know, however you're building it, right?
Yes, yes.
So I always thought, well, look, I mean, suppose, just speaking very generally, if consciousness is a kind of non-well-founded structure, that's not a barrier per se to physical realization, but it does mean that you need some kind of external scaffolding to put all those pieces together. Does that make sense to you? Just in the way that you need this kind of external scaffolding to put the 3 rings together from outside of it, so to speak.
You would like to know whether you could, right?
Yeah, just speaking generally about non-well-founded structures. So there's no problem
I have
physically
no I have no problem doing these kind of constructions with things like this for these well-known, well-founded structures. But if I want to make a conscious entity, I know how to do it without getting outside, but that requires a different kind of conversation with other human beings. It requires,
Yes.
it requires making a baby. And then we do make conscious entities, but we
Yes.
don't know how they're made. We are
That's
actually giving in to nature to allow nature to produce them.
Yeah. Right. But what I'm getting at is there's no barrier to thinking that not some kind of non-well-foundedness is essential to consciousness and that that's physically realizable. Because there are people who want to say because of this non-well-foundedness, it can't be physical, as if there must be, the body on the one hand, the brain on the one hand, and some, I don't know, conscious souls or something that are, however,
Well, yeah,
stuck in
right.
your.
I don't think of non-well-foundedness as an abstraction at the
Yes.
physical level.
Yeah. I don't even.
But I do note, and you note that a lot of our modeling seems to be based in standard set theory, but that doesn't mean that physical modeling has to be based in standard set theory. So, yeah.
Right. Yeah. Good.
You could imagine a very a very convinced graph theorist who thinks of graph theory as the basis of the mathematics, and he will rewrite everything in terms of graph theory. And graphs have loops to begin with, and why shouldn't they?
Right.
That's kind of Axel in a way.
Yeah.
But this matter of being consciously inside the system is a um, is a is a characteristic of consciousness. Um, if you take that seriously, then how could you imagine being outside as outside of the consciousness that you're trying to build?
Yeah. Well, just by abstraction, just the way you kind of think about the world, the truncated world, as old Gustav Bergman used to call it. That's the world without the mind is the truncated world. So, and as you know, like when we kind of think about the physical world, we engage in this kind of abstraction from our own experience of it. At the same time, there's some kind of basis for it because we know we don't create ourselves in the sense of, unless some kind of strange metaphysics is true, like Vedanta or something, we don't like literally make ourselves, and we encounter all of these kind of constraints and kind of the materials of our experience that we don't create.
That's right, and we know that we are in fact parts of various conversational domains.
Right. And
And
we all
and that
exactly.
what
So
we call our consciousness, if we look at it, is often oh, that's part of a larger conversation that goes on in this direction, and
yeah.
another part is a part of a larger conversation that goes on in another direction, and you can't really own any of it as though it were cordoned off.
Right. So there's the kind of a basis for this sort of abstraction into the notion of objectivity, even though it's always our experience of it's always mediated through. So if you just kind of play the same trick, like to your own consciousness, then you think, well, yeah, it is. My subjectivity is objective in some sense, even though I only have access to that by this kind of move of abstraction. Like whatever my consciousness is, it's sitting in this physical room right now. It's on this planet and happening at this time and this bigger scheme. So,
Well, I guess you can have some fun asking where it is then, right?
somewhere around
I
here.
mean, yeah, I mean we carry various metaphors for locating it, but
Right. But even if we couldn't precisely locate it, the sense that like there are other conscious beings that are who are not me, that's already also a notion of objectivity. Like they're out there, you know. I don't have complete access to their inner lives. They have, an access to their inner lives in ways that I don't. So, and that's an objective fact. So it's like the objective existence of subjects.
And in our social interaction, we easily give way to, yes, I'm speaking to another conscious human being, with a few clues. We could be fooled, but maybe not for long, actually. There's a complex of interaction that tells us that we're in the presence of someone else.
Right. Yeah. So that's I guess that's a long-winded answer to this, how you might sort of think about the problem of consciousness as and the problem of your own subjectivity in a kind of objective way. The crucial thing, though, is in doing that, not to evacuate or, evacuate your model of everything that's actually crucial to subjectivity.
Including the
But
experience as a space. Yeah.
Yeah.
But do you imagine that you could build it? I mean, I can build the knot. It's a non-well-founded structure and I can build it. But if I wanted to build if somebody gave me a recipe for building a conscious entity and I could do it, like I buy the kit and I put it together and it works,
Yeah.
I might begin to be convinced, right? Like when I was a
Right.
kid, I was convinced that amplifiers behaved the way they did because I built one from a kit, right? But
Yeah,
it's
sure. I mean, but
another story.
I imagine if we could, but I wonder if it's not simply sort of the recipe for building conscious entities is not so complex. Maybe, I mean, I don't know, but it could be so complex that no human being can actually understand the recipe.
Yeah, and we have to remain open to the possibility that there is a whole physics that we haven't yet understood that we need to understand the big picture. And that's why it's also useful to kind of put into bracket this question of so-called neurophenomenology with the kind of realization of
let me throw a question at you. We have some pseudo-conscious entities floating around now, like ChatGPT, right? You can converse with them. You can give them a problem and they will solve it. Sometimes they will summarize things for you. They will discuss things with you. Do you think that, but probably you still feel strongly when you interact with one of those, well, this is just a computer that produces text and I can interact with this text, but it's not a conscious entity. But how are you going to feel when it becomes more sophisticated in 5 years? Are you going to give consciousness to those entities when they begin to behave with great verisimilitude as conscious entities?
I mean, yeah, we might be in a position where we just treat them like they're conscious, but they're not.
Yes, but I think that's what matters to us.
Vice versa.
What matters to us here, because we understand that science is limited in its explanatory power, and we want to be scientists as much as we can, is whatever we can account for or model within the framework of science. It doesn't imply that if we can simulate consciousness, that the simulation is conscious. Like when you simulate the universe in supercomputer or in astrophysics, nobody will believe that, oh, the galaxy that I'm simulating is the galaxy. Already, we would like to be able to have a strong model that can link all those things without having to commit to claiming that, oh, if you have that, that's a sufficient condition to be conscious. We have to remain more modest But there is quite a bit of work that can be done, I believe, in those directions. So I would say, I mean, at least me, to Grégoire probably, and I guess to Ken too, that's that's the perimeter we want to remain in. We know that we cannot explain everything.
So for me, there's still something which is that's in your presentation. Like so, even if you can have a system that is aware of its own states through let's say feedbacks, it's difficult for it. It would be difficult for it to define what is meaning. And I think that like there's with the work that you're showing with self-reference, there's probably a link with trying to define what meaning is. And if a machine is conscious, it should be able to capture like object meaning as we do, and then make it objective in a way that is communicable, like something like a shape, or like trying to capture a phenomena, but in a way that is like is the right way, and you can convince people that it's the right way to think about it. So I think like this idea of behind consciousness in general is related to trying to create some meaning. So I don't know if you like you relate what you were explaining, like this self-reference, how you relate it to making meaning.
Can I chip in?
Sure.
Because related to this, I was already familiar with this naming and Gödelian shift by Lou explained today, but today I just came up with this idea that the self-referentiality that Lou described today, I suddenly realized that there is something important that we could think about here in this context related to self-consciousness, because the way Lou explained how formality and its interaction with the I. So in this sense, through this interaction between formality and I as a being, we get this possibility of obtaining this phenomenological value in the formality. And that's through this interaction between formality and being. And I thought it was quite important, and that's something that I didn't realize before either. And in this sense, we can redefine the relationship between being and language as well in terms of consciousness. And so this naming shift could be useful for explaining this self-referentiality in self-consciousness. What do you think, Lou? Like, I mean, we can talk more about it in a few days, but I don't know if other people also.
Yeah, that's right. That's what I was talking about, that
Right.
that when you engage in language, you engage in something that you can detach up to a point. So you can write it out or you can say it. And it's necessary because it's all part of our conditioning that we are communicating with others. So it has to be detachable in some form. But that detachable means that we also have to take it into ourselves and make it part of ourselves.
Mm-hmm.
And when we do that, when we take a word and make it an actual part of ourselves, and I was talking about naming, so that becomes, say, your name in relation to my experience of you, it has to become integrated. And when that is integrated, then we begin to have the meaning. So that's not meant to be a definition of meaning, but it's an example of meaning arising. And in the Goedelian situation, it's the same. The reasoner about the formal system is taking on the meaning of the system and what that and how the pattern of the rules of that system work. And it's through that meaning of the system that he is able to come to reason out that it is incomplete. So without the system isn't even incomplete without that reasoner there to complete the loop and make it possible to understand what happened. So,
Yes,
so the consciousness that's involved in, say, understanding Gödel's theorem is the consciousness of the reasoner, the interpretant, and the formality, and both are necessary in order for that consciousness, that particular consciousness, to come into being. So in a certain sense, every time you engage in learning something or dealing with a formalism, you are building consciousness. You're building it by that kind of an interaction. And you've done it so many times ever since you were a little child that you don't quite realize that your consciousness has been, what you call your consciousness, has been built up out of millions of acts of that kind. And you're always doing another one.
Mm-hmm.
But Louis, if I may, because yourself in your very nice slideshow, you showed examples of analogies, at least, that were kind of not linguistic, like the Canisa triangle at the level of perception. And at least at this point, we don't want to assume or require that consciousness necessitates language. So we want to think about those self-referential structure, those non-well-founded organization at the level of something that is not necessarily associated with this type of consciousness and meta-representation we are talking about, but built in the, I would say, the passive synthesis of Husserl's, built into the very basic phenomenology of subjectivity, of space, of perception, of imagination. Like other animals probably are conscious, and they don't have the same type of articulated language or reasoning capability we have. So we want to, when we started with Ken working on that, we started with all this non-well-founded stuff of staters, and all of those were those references. But we realized that to make the connection with phenomenology, we had to, with some fundamental phenomenology, we had to attempt to think about it without the need of that type of language. So if you want to think about the
some kind of language will intervene. It won't necessarily be a full-blown English language, but you have your direct apprehension. And I mean, maybe no language at all except just being an animal in the world, and you're still conscious, right? I mean, your cat is conscious probably, or your dog.
Yeah.
But maybe you yourself, without any particular descriptive language, you remain conscious, right?
Exactly.
But when I brought up language here in this context, I didn't mean natural human language. You know, even like you want to model something, that itself is a language already.
Yeah, exactly.
So in that sense, like
yeah. So, but can you think about it starting from the phenomenology of space? Is there something we can think as circular, non-well-founded, so that we can connect this framework we have been discussing, this concept, to something that would be spatial? Of course, you do it with knots, with topology. We are trying to do it with projective geometry or group theory or other sort of things. That's what we are after.
No, but okay, so the thing is, the analogy with the space comes from the fact that when you put, it's really the idea of naming, but you name what you represent through where it is. And so by naming what the object is through where it is, then you can have this kind of similar problem that can appear, which is that you can take a reference frame on where you are, and then there's an ambiguity between the way that you name the things that are around you and the frame that you use. For example, if you have an affine space, you put a frame. Then if you're going to choose a frame, then you can always see it as a vector space. And then there's a lot of different ways of doing it. But the ways of doing it depends on the way that you choose a frame. And you can see the observer as being the frame in the space where it is. But they're still naming objects through the way that you represent them in the space where you are. So I think behind space, there's always something about naming, because you distinguish the objects, and you also say more than distinguishing them. You say who is close. You talk about neighborhoods. Talk about proximity, not necessarily relations in terms of arrows, but in terms of
Well, all the things that you're talking about are different aspects of distinguishing, and the base thing is that some distinction occurs, and the distinction occurs with awareness. So I don't know how to separate consciousness and distinction. An act of distinction is an act of consciousness.
Yeah, I would agree with that. Yes.
Yeah,
Sure.
and we find Varela and Francisco it would be among us.
I don't know if you have much more time, but because I had some technical questions, and so I don't want to cut the talk. But I imagine it's late on
Oh
your.
no, go ahead if
No, but
Louis
it's
is
late
okay.
on. It's late on.
Ask.
Okay, so there's one. So so let's go onto this. So like the self reference that you were talking about. Do you need to have a map, for example, G to formula? So map that's something that's gonna map a natural number to a formula. So okay, you give this example
Well,
for
the Goedelian
exactly.
example
But
has some extra structure, right? You have a way of coding something. The shift gets to self-reference in a simpler mode.
but you get it from so my question is, so let's say for the shift, if I look at the categorical pairs you were introducing, it's still something that goes from, for any object you have a map you choose a map, which is the shift, and you still have this thing that it basically lives on something that is very huge or like infinite. And would you think that could there be a constructive way for an agent?
Well, let's ask how huge it is. I'm sorry, I didn't mean to interrupt you.
No, I mean, I have the feeling that it's like n, right? It's infinite.
Well, how big does it have to be? That's a nice question. Yeah, you were in this because I'm talking about what you do, and you're a big system, and I'm a big system. So I notice I'm big enough to notice that I have a naming operation, right?
Yeah.
And that I do shift. I do the shift. I notice that I do this shifting. And then I say, well, I could have a name for that. I name for what I do. And if I do have a name for what I do, then that will get shifted as well, because shifting occurs. And then self-reference is arising. And then you ask yourself, well, how is that related to the self-reference that I actually have? And I see that it is actually related to that. But yes, it involved a system that was large enough to be able to observe its own interactions in that way.
But
A human being can notice that it thinks. It's part of that same phenomenology about consciousness. We realize that we have thoughts. We realize that we are conscious. We're a large enough system to have that much self-reference to see that it's something that's going on.
Right. And to make distinctions between types of consciousness, perception, thinking, imagination, and so on.
And if you wouldn't wanted to have it in a constructive way, like for example, something that is naming or making sense, but in a non determined way, something that evolves through time, and like let's say I know that I can name, but when I can name things that I didn't know about in the past, and I still have a process of naming or have a process to think about stuff, like maybe more formally. But would it be possible to think about a system that is not as huge as a human who cannot see its own thoughts, but who can formulate, name stuff, or talk about them algebraically, like but without having a priori all the statements it can say. So it's just start constructing statements little by little, and then it keeps also its self-reference in the way that you define it, but the way going at the same time building its naming system. You see, like trying not to have something that is not to talk about humans, but try to keep this self-reference to more, let's say, machines that have a process to formalize stuff. And I don't know if it's very clear if I'm very clear to what I'm saying, but I mean, like, would it be possible to imagine a system like you're creating the function G to F one after, like you start, you do it for one, then for two, then for three, and you are building this self-reference at the same time.
Could be.
But do you
Yeah.
know, would it work in your formalism? That's what I mean. Like, would it work? Do you have an idea of how, without having a priori like this, so something where you could like these systems, you have formulas, so logical formulas. I'm not very familiar with the logic and uh, like how to. I never really looked into Gödel's theorem, so here I don't know how the formulas are built. But like the map N to F is you assume that it exists, right? That I mean you can, but you don't build it recursively, or or are you building it recursively?
Well, if you want to have a system that behaves well by following some formal rules, then you usually have to explain to it what it means to behave well. So, for example, if we have a computer program that plays chess, it's easy at the programming level to tell it what it means to behave well. You must look to checkmate the opposing king, um, and you tell it what it means to win. And it turned out in the last few years that it was enough to give the system, if you make a system good enough, just the rules and what the aim of the game is, and it proceeds to play games against itself and learns how to play everything really strongly, right? So if the goal is very clear, then you can make it do things. But if the goal is as diffuse as some of our human goals are, then it's not easy to make a model that would behave like us.
So you don't you think that the self-reference that you were defining in these in your work, you could apply it to for like limited formal systems that like for example with a very basic language, I don't know, you have okay, I'm making things up, but you have saying very basic stuff, but you have a Boolean algebra times n, so you have n variables, and you make the agent formulate some some product of the sum of the variables, but he can do it only in a recursive manner. So he's like he's not allowed to formulate all of them at the same time because he's basically exploring his environment and getting truth value little by little.
Well, I don't know. Let's take learning names. I was ignoring most of what's involved in learning, right? If I'm to learn that your name, how do you pronounce your name? Grégoire.
Grégoire.
How do you say it?
Grégoire.
Grégoire.
Yeah.
Grégoire. All right, but by now I recognize you. I think I would know your name again if I saw you again, right? But that's a very complicated thing. It's not part of my formalism. I don't know how it's happening, right? That that the distinction that you are for me begins to become recognizable, real for me, and that I could associate it with your name. How is this done?
Part of it probably is unconscious, and we get the outcome of that. So we have to be careful when we manipulate all these concepts to kind of not want to over-determine, if so to speak, the generative model or at least the content of consciousness, the shifting, I guess, as part of it in its phenomenology, you can sense it somewhat. But some of it is beyond reach in terms of the process. So that's, I mean, I don't know if it's useful in this discussion, but it just wants to make sure that we are careful not to mix in the same bag stuff that we have to ascribe to quote unquote unconscious processing and quote unquote conscious ones. Just a remark.
Well, I do think that the idea that you put forward as a group of listing properties of consciousness that are important, and then keeping them in mind to try to understand what consciousness is about is going to be helpful. We don't know how to build it, and maybe we can't build it, but it has certain properties, and some of them are hard to articulate or hard to say, particularly the ones that are kind of self-referential. Consciousness, having consciousness is a direct matter. And how do you articulate that? I don't know whether the problem of constructing it is is a possible problem. I don't know whether it can be done.
And do you know what kind of these functions that allow distinction would have this kind of self-reference arise? Like, because it seems to me that the so you're saying if I name, then I'm able to, the process of naming is the thing that is, in all what we're discussing, is the thing that is considered as it's primary to everything. The fact that we can name, and so because we can name, there's already the possibility of self-reference, or like saying that because there's for us on our side, because there's a space, there's an observer. So because you can name, you can self-reference, because already in the fact of naming, there's basically something that does. But like if a naming and distinguishing is like related, would there be like some good class of distinguishment that allow for self-reference in the way that you described? Or would you think that it's not a good criterion? Like when you distinguish, you can always in some way self-reference yourself. So it's vague, it's not precise. My question is vague.
Well, we also don't know what it means to distinguish or to have a distinction. It may be the same question. What does it mean to be conscious, and what does it mean to be able to distinguish? I suspect it's the same question.
And how do we distinguish, sorry, because how we distinguish this particular type of distinction from, let's say, what most, machine learning algorithms now can do? They can perfectly distinguish an elephant from an apple and do classifications based on some sort of features at their input. That's not what we are talking about. Or is it?
When I speak of a distinction, I mean a distinction for someone.
Yeah.
And so it's accompanied by an awareness.
Yeah. But one of the points I think Ken, Greg, and I have been thinking about, like many others, is that this somewhat is fundamentally related to some sort of self-reference, so to speak, and that as a manifestation in the subjective experience of space.
Yeah, sure. Yeah. I'm just reminded of something that Jean-Paul Sartre says. Consciousness is the being through which negation enters the world. And it's pretty much what it means, is that you don't really get distinctions. It's not that he's saying that the world, the truncated world, doesn't have some kind of structures and patterns and differentiation in it. It's just that there's no the way sort of there's no negation really the way we understand it in the world absent consciousness. Absent this kind of distinction is always a distinction.
But consciousness can also be conscious of the unification as well as the difference. Right?
That's right.
So,
it's always both of them.
Sartre's statement has two sides.
That's right.
another
They're in-
side, another way, another phrasing that's on the other side is Spencer Brown, who says a thing is identical with what it is not.
That's
So one of the way we try to approach
And
this
if a thing is identical with what it is not, then you erase the distinction that that thing is.
yeah, and then being and nothingness.
that's right.
Yeah.
Yeah, well, for start, consciousness is also the being that is what it is not. Even
And so one way we have been trying to think about it more geometrically, sorry, I always come back to that, is through concept of dualities. So this, things that is and that it is not at the same time, maybe it's a duality of sorts. So in ambiguity, in the sense of duality. And we are trying to work out, Grégoire, who is the real mathematician among us, is trying to work out, different type of dualities. We have worked with Daniel Benkin also on projective
Or
dualities.
what kind of duality are you thinking
Yeah, well,
of?
maybe Grégoire you can talk a bit about it.
Yeah. So no, but it's just the one. It's a basic one. It's active, passive frame. So the fact that you can always frame change as an action, or at least if it's an action that. So assume that you have an agent and it does actions. And its environment. It can see it as changes, but it can see it also. So actions is moving, for example, moving its arm. But here, let's say moving itself, displacement. So then there's a change of frame, which is a reference frame. And so for if you so this is just very basic. Now, just the thing that I was saying with the affine space. In affine space, you choose a point, and then you can choose a basis vector, and then you can see it as a vector space. So the vector space is where you trace your experiments, right? But then you can change frame, and it doesn't change anything. But the thing is that every time you choose a frame, you make a choice, and this choice is from the one who makes the frame, and the one who makes the frame in our setting is the agent, because the agent has sensors that are affixed to the body of the agent. So there's a difference, let's say, between for itself, like it's always in its frame. There's a notion of self-frame for the agent, at least in the way it rebuilt external information were embodied at a point. So there's really a notion of frame. So this is where the idea comes from. It's in the model, you have an agent. This agent is always embodied, so it has always the same position, so it frames itself, and when it moves, it does a change of frame, so it moves just so the space in which it represents the environment, there's a group acting on it, or let's say there are some actions, but let's say for instance a group which are a representation of translations and rotations, but not necessarily in a way that is Euclidean. So you can have a group action which is different, so projective. And so the idea is to say just a very common thing, which is this duality between change of frame and action, and just remarking that so this is another kind of duality, but if you look at the G space, so like group acting on the space, it's just a functor. And you can state Yoneda lemma in this setting. And Yoneda lemma is kind of telling you you choose a point which corresponds to identity, not moving. So here for a group, it's really this. But when you have a group acting in space.
Excuse me, let me interrupt for a moment. I'm kind of I understand what you're talking about, but I don't quite understand how you're bringing it into relevance for talking about consciousness.
So the aim is to talk. So the aim is to the problem is we have an agent, which you can model as Markov chain for hidden states. So it can represent the environment. In this environment, it's just a state space, and then it moves, and so it can know the consequences of its moves on the environment. But now it needs to infer the environment through some kind of sensors. And the thing is that in this setting, the idea is to try to know So here the changes of the actions, the consequences of the actions of an agent, they are given by a change of frame. So let's say just another way, there's a group acting. It's the actions of the agent correspond to a group acting, an element of a group acting on the state space. And the idea is to try to say, can the agent be conscious of itself? So you can ask, can it distinguish its own action from the rest of the world? But then the question is tautological because it can always choose its actions. So it can find always a way when you model it to choose an action. And the fact that in the model you already have a set of actions means that it's able to talk.
Excuse me, let me interrupt again with a question that's coming up. It may be that what you're doing is speculating that as we evolved as beings that can handle movement in the world and change of frame and all those things that we need to be able to do as animals in the world competing for our living, that then enough of those constraints give rise to what we're calling consciousness. Is that the thought that's in there?
So the thought that behind is just through the way, so if we represent stuff, so in sense of functions over a space, or maybe more generally, we represent some structure. I don't know this. So for us, it's really there's a space in which you have stuff, which are positions of objects. So more formally, this is the concrete example, but more formally, you have, let's say, a space on which you can act through your actions. But then you model an agent like this, but the agent is not conscious of itself. It just represents things that are from the environment. It represents its own action, but you can always implement it so it does a certain kind of actions. And now the idea is try to see, can from this this kind of model, can there be a self-reference that appears directly in the setting from which that the agent can exploit? So it means that is there a way for the agent to start realizing that in fact it can track its own positions, but simply through representation, or that it can start knowing that it thinking about the fact.
So an example might be, at least in some people's opinion, a cat is an example of an agent that has not very little self-awareness, but an enormous awareness of handling itself in its environment. And you could wonder whether that cat could evolve a step and become highly self-referent, conscious. You could wonder.
So yeah, exactly. But here it's really a concrete, like basic model of agency, which is used a lot in reinforcement learning algorithms. But the aim is to really start to first explore what is the self-reference of the agent in the environment and the actions that it makes on the environment, but also really to find a way to exploit this kind of so the agent has just access to the way the environment is and its own actions. But if it can start to think about or to talk about using just rewiring the way that it's referencing to the environment and to its own action, rewiring so that it starts talking about itself, to talk about where it is and how it references the environment, then you could imagine it starting to do tasks that you didn't want him to do at first. So it's just to try to see how to confine it to when you force an agent to be doing a certain task, is there a way for it to exploit some kinds of ambiguity in the environment to identify itself to the environment, which is what Gödelia in this setting tells you, because any point of the environment is a possible choice of reference. It's a very basic statement. It's just saying that you can. It's just saying that you can choose any point in the orbit as a way from which you can send from when you no, it's more subtle than this, but it's I need to remember. Yeah, it's the fact that you can say not acting is any point in space, but you need to choose a point. And so if you do this, then from there you can rebuild all the other rest of the space to all possibility of actions. But so the aim is to say that as there is you can see points in the space as possibility of you being there and referencing the rest of the environment, you can start to, instead of solving tasks on the environment, solving tasks about your own position, your own configuration in space, or which is the only thing that in this model allows you to talk about yourself. And then doing this, maybe having an agent exploit some kind of lack of things that are underdetermined for it to be able to do stuff that you didn't ask him to do. It's really to force constraint system to see if constraint system can exhibit some kind of self-reference to act in a way that we didn't want it to act in first. I don't know if it's very clear, but the aim is to say, in the environment, the way you represent, there can be some you can have a notion of self-reference through dualities between the way that you represent your environment and so the way that you represent your environment basically tells you something about yourself, and then exploit it in a functional way so that the agent can do stuff that you didn't implement it to do. So.
Well, how does it work with us that we evolved to use self-reference? And we do, right? If we are in a physical environment, competing in a physical environment, then we can say, oh, I'm here. We can consciously say, I'm here. I need to get something to get to there. I need to find a way to climb that tree, or I need to build a certain thing. And we go through and use the fact that we can identify ourselves to enhance our ability to survive in the environment. We did evolve that way, human beings.
Yeah, there is something very important to make as a distinction here, is that what we are after, and that's why Grégoire is emphasizing this sort of minimalist model, is not a process by which, for instance, oh, I can literally take a perspective of me being there, so having some sort of internal quote-unquote representation of my body being there, and I can kind of recursively think about it. Now, we are trying to find something more fundamental that would be in the very structure and would be a necessary condition, actually, in the so-called self-consciousness hypothesis. The idea is that there is this pre-reflective self-consciousness without which we would not have any other form of consciousness. So we are asking ourselves, okay, what in a kind of basic spatial model, because we go into that because of its connection to intuitive phenomenology, without having to involve some sort of reflective projection and recursive process, explicitly recursive process. Is there a kind of structure and that have this property to begin with, and can that be eliminated by dualities?
If you're going to talk about spatial model or using space,
yes,
then I think you have to look at it operationally, because we are not actually given some topological space around us, which is given to us. There is no a priori space. What you have are actions that
we don't build. Maybe we have
or
agree
you
on that, but we do believe that that's the fundamental.
What you do to build space for yourself is certain actions that you know how to do. So the space becomes different after you learn to walk. You learned to walk as a child, and once you were able to walk, you lived in a different space, and on for each of those many different kinds of actions.
Yes.
When you looked through a telescope and you saw that the moon really was a round object way up there, it changed your whole notion of space.
No, that's for sure. You enrich it. But what we are saying is that there is an a priori space that you're born with, and it's probably
but why do you even believe that?
Well, because
I don't believe that. I don't believe that. I have some mathematical
I know.
space,
I'm not surprised.
And I look out and I think, well, my brain constructs a space, but I don't know what I'm really looking at. I know that I have these coherences that I can get across the room. And it's a graphic guide that I'm looking at. I'm in a certain kind of computer graphic generated by my brain, and I call it the space. But as for there being an a priori space,
No,
No,
that
no,
I
I mean,
agree. But exactly, but the
maybe
thing is
we
that
disagree on the, maybe I'm mistaken in terms of what we understand by a priori.
but the idea is that we rebuild space from a sensory input, and it's a reconstruction. This is like, but the thing is, the thing we're trying to see, I mean, is there already in this notion of space the possibility of self-reference? And the thing is, it's already a broken problem.
yeah,
because
and I think the answer is that for us, yes, there is. There is the possibility or the actuality of self-reference from the beginning.
Yes.
Mhm.
But what type of space?
From,
What type
from
of
the beginning of
geometry?
what? I didn't understand. From the beginning of what? You mean from the
beginning of every distinction that you make at every point in time.
No,
Yeah, I kind of agree with that. Yeah.
Did I need to think about it? Okay.
So
I didn't.
one of the things we have tended to kind of, we believe more and more in, because we have a lot of evidence, both from psychology, from phenomenology, but also there has a lot of predictive power for certain behaviors, so to connect phenomenology to function, so to speak, is that one of the fundamental ways we represent or we experience space is through 3D projective geometry, and that's, to me at least, and we could argue for hours, I have many arguments for that, but that's something that is almost given as a regularization principle for situated agent autonomous systems that are cognizant like us, that they actually build their, let me use representation first, so their representation of the world and themselves through a 3D projective space and the action of the corresponding projective group. And then, of course, with experience, all of that gets calibrated. You can build metrics, then you get a Euclidean space, etc., and you have a lot of things. But the fundamental things that we started from with Ken and other people, then with Daniel Benkin, another mathematician, is that one of the good potential model of this kind of most fundamental space of subjective experience is that it's structured by 3D projective geometry. Then we started thinking about, okay, how does that could connect to pre-reflective self-consciousness? And then we thought, okay, with Daniel Benkin, who was the key for that perhaps we can think about projective dualities in, dualities between point and planes, and reversal of frame. If I look toward an object, it seems that it looks towards me at the same time. There is an ambiguity, it's in the duality. Then Grégoire elaborated further on that, moving away just from the specific model of projective geometry to look at homogeneous space more generally. Then he brought the Lionel lemma, and that's where what he was saying before is coming from. So we are not, I'm not sure, we're not sold on the thing, but we have this object, this sort of conceptual framework, and we want to see where it can lead us, push the things the farthest possible. And if it doesn't give us what we want, we have to think about something else. But we're still thinking that maybe there is in the context of situated agents that are kind of equipped, so to speak, with this type of geometrical way of processing information, maybe there is in there something that is fundamentally already alike to this type of self-reference.
Well, I mean, I agree that that projective geometry is very fundamental. I'm also aware that some people like to align their perceptions with space and counter space, a la projective geometry. For example, the Steiner people do. And then that's a very beautiful thing to investigate. I don't know if you're thinking that it will help you understand how to construct conscious entity, or whether you're thinking just that it speaks to the roots of consciousness.
Yes. And then it has very nice properties because it allows you to understand certain type of drives when you put it in the context of, for instance, situated agents that are doing active inference, and you have specific formula, for instance, to understanding curiosity by through information maximization as a result of action. And then when you put into that framework geometry, and in particular projective geometry, you get very interesting properties that the geometry itself yield a drive that makes agents want to explore their environment. They want to go see what is at infinity, what is over there. So there's a nice connection you can make with behavior then. And since kind of we are interested, maybe wrongly, to connect some aspect in relation to evolution, notably, of that fundamental phenomenology of consciousness as kind of something that manifests spatially and actual behaviors, adaptive behavior. Why is it that we like to explore stuff? Well, if you have projective geometry and you use epistemic value as a quantity, there is formulas you can use. You think about how geometry, the action of the group subtending geometry, modify or influence this epistemic value. You find out that if the space or the group is Euclidean, you don't get exploration behaviors. But if it's projective, you do. So you see, we're also trying to connect to behavior.
The thing is, yeah, but it's not just for projective. It's for the thing is, this is of course a bit the way you define the problem, but it's just the fact that changing the group action on the representation space group, the way the group act corresponds to the group, an element of the group is an action of the agent. So you can make it really in a way that can work on real data. So you have a way to map. For the projective group you can, but you have to choose a way to map the translation and rotations to an element in the projective group or the general group that acts on your state space. And if it deforms the points that if it basically distorts the notion of a volume, then in this case you will have a drive. And so in the Euclidean case, it doesn't happen. And the reason why it works is because you break equivalence, because you always choose when you're going to quantify the uncertainty of your sensors, you're always going to use a fixed frame to do it. So this is like something that is you would expect that if you do a projective transformation and you want to compute the notion of volumes, it doesn't change. But the reason why it changes is because if you put a good notion of volume, the reason why it changes is because there's a moment where you have to choose a chart, and this chart is the one of observations. And in this case, it introduces really it breaks completely equivalence, and so you can have a drive.
But the thing is that if you take any mathematical structuring that speaks to one's experience, it's mathematical also, which means that it has its internal structure, and everyone we seem to be built with curiosity about both sides. What does it tell us? How is it affecting our observation outward? How is the internal structure available to us? What do we see in it? And so we become very curious once these models are put forward. So then it's a question of how strongly you can penetrate them, and different people see different things, right? But it could be projective geometry, it could be the differential geometry of the space-time universe, it could be any of these things. They all pass the definitions or the framework is an enormous possibility of curiosity about one thing and another that's related to it.
But
Yes.
Like the simplest thing is numbers and prime numbers, and we can be very curious about prime numbers immediately.
But here curiosity, so there's curiosity about the mathematical structure and how to apply it for function, like our curiosity to apply it to functional, to get behaviors. And there's the notion of exploration drive for an agent in reinforcement learning, which is basically mutual information between observation in the future and the beliefs on your state space. So this is just a way to, let's say, see. It's very practical. It's just you have a certain model, you put a structure in the space. Can you distinguish by the behaviors of the agent the action of the group that is used to represent the actions of the agent? So this is like there's a but
and there are different groups depending on what kind of transformations are involved. Like a person could get very curious about this three-dimensional phenomenon of things can be linked with one another, right? And then you are led into topology, and the groups are groups
Absolutely.
of homeomorphisms. They aren't they go beyond the linear, but then there are linear groups as well. There always are groups of symmetries involved.
Yeah. But again, what we are talking about is not even at that level of development where you start being intrigued and interested in thinking explicitly with all your full-fledged mature or maturing human consciousness. We are talking about the fundamental way, even before we speak, just when we are born, that space is processed by us and how we representing ourselves in that space. And based on, for instance, the phenomenology of very basic visual perception, but it's not only visual, we talk about that for hours, but also the ability to take perspective by imagination. I can, of course, when I look in front of me, let's say you take railroads in front of you, they seems to converge at infinity. It's not just on picture. You have a three-dimensional experience of the rails converging toward infinity. That's not
you certainly do,
related to angular projection on the
you have a three-dimensional visual experience of the line at infinity.
Yeah, but it's definitely not Euclidean. It looks more like projective. You can account for a wealth of visual illusions, like the moon illusions, combining the type of optimization procedure we were talking about and projective geometry. So we say, okay, projective geometry seems to have a very 3D projective geometry seems to have a very fundamental value to account for a wealth of basic perceptual and imaginary, in the sense of very concretely a situated agent imagining itself at a different point of view, and therefore it anticipates how it will perceive the world. It will perceive it in a projective manner if the basic perception is projective, and the relation between the two is a projective transformation. So that's, we started from this very basic phenomenology, and then you can start connecting a lot of things. And you say, okay, agents that are equipped with that, then now if they are trying to optimize or maximize epistemic values of their action, then actually the fact that they use this type of group and geometry make them want to explore their environment, whereas if they were Euclidean, they would not. And Euclidean geometry would not account for the fundamental aspect of perceptual phenomenology. So that's where we started from. So from there, we want to assume, okay, there is some validity to that. So let's assume that some sort of geometrical model like that, perhaps projective, we have a strong reason to believe that is at the basis of, even before you start being able to explicitly think about things. So now the question we have is that, to go back to what we were discussing before about the features of consciousness, self-reference, etc., pre-reflective self-consciousness, is from this framework, what is in there intrinsically that talks about that? Is there some properties in there that we can link to that type of features of interest? Well, there are certain dualities, perhaps, that are interesting in projective geometry. We wrote a paper about that with Daniel Benka that gives you some sort of aspects of why when we are observing something, it feels like we are also observed by that things, potentially. When I look at the skies, it feels like the skies is looking back at me. That kind of feature, you can get them through projective duality. So we say, okay, well, that's a good sign. Maybe there is something there. And then with Grégoire, we are going further than that. We're considering other type of dualities. Just to go back, give you a bit of the story of why I started talking about dualities, ambiguities, and how relevant potentially they could be to thinking about how this kind of self-referential structure could then be kind of thought into kind of a spatial phenomenology. So that's, I'm sorry, it's a lot of information. I'm so glad to talk to you, actually. We should have done that way earlier about it. But that's where we are at, and that's what we are working on. And
have you thought of looking at finite projective geometries?
Somebody raised that point recently.
You see, like, think of the Fano plane and how it's related to the octonions and then you're not so far away from self-referential algebras. It's a very
Interesting.
very perspicuous system that's related. It's not just related to the little finite geometry, it's related to logic, and it's related to the structure of space as we work with it, four-dimensional
Not just
space.
planar geometry. When you talk about the
Right.
plane, here you are saying that we can
Yeah.
we can think from there also about 3D space, correct?
Right.
Interesting.
Right. So I'm saying you can often start with some very tiny, what appears to be a tiny subject, tiny structure like Spencer Brown's calculus of indications, but it unfolds into things that are related to your experience.
Yes.
Octonians are not as small as the calculus of indications, but in the round of other things, they're fairly small, and they're related to the Fano plane, and then they're related to the projective geometry.
Yeah. So Daniel Benka, I'm sorry, he's not here, and I don't want to put word in his mouth, but often has used this type of basic structure to help us understand what he was talking about. What do you think about that, Grégoire? Do you get what Louis is saying? And
yeah, it's nice. Yeah, it's interesting too. It's true that I mean, I'm not working. I mean, I'm not focusing that much on projective geometry anymore. But I think it would be interesting to change the group and to see what we would get. But the problem for me is to try to compare different group action on the same space. And so I look at representation of the group, but non-linear representations. And so in the end, I don't get very good stuff. So I'm basically trying to see something a bit different on my side, but more trying to compare different topologies on the state space of the agent. But anyways, yeah, I think it's of course this is very good direction to keep applying projective geometry to other, like to keep the spirit of projective geometry, but in not with the projective group. I think that's nice, yeah. Not with the projective group that we consider now, up to now.
I have a topologist's remark about projective geometry for you. Let me see. I should just do this on a sheet of paper rather. Oh, no, I'll do it on my pad. Let me show you what I have in mind. You'll like this. It might be of use to you. Let's see. Okay, so here's the projective plane, all right? Antipodal points are identified.
that is great. I know exactly where you're headed. We're going to have a nice discussion.
All right. So that means this point is identified with this point. And if we were to draw a little strip in here, I'm sure this is what Mobius thought. You see, in the projective plane, there's this little strip which goes from one side to the other. But if you identify according to this rule, which you have, you see that the Mobius strip is embedded inside the projective plane. All topologists know this, but you see, what did Mobius do? He said, well, I think I'll draw a picture of it. And he drew it in 3 space and gave birth to the Mobius strip as we know it, which is a finite a bounded compact topological object in 3-dimensional space. Whereas this is living in a different way of thinking about the geometry. So I just wanted to mention that, right? That out of the projective space comes the topology of the Mobius band.
Yeah, and you know, we had a debate, including in the paper I mentioned on projective geometry and reflective self-consciousness with Daniel Benka, because I had this intuition, but I'm not a mathematician, so my intuitions are always that actually aspect of this pre-reflective self-consciousness as manifested through kind of the experience of space could be related to the gluing of antipodal point in the
It could be related
space,
to, could you repeat that?
to the gluing, the topological gluing of antipodal point. That's what you usually show, which is true in the plane, but it's true also in the space. And so there are those quote unquote great circles. And so I wanted to think about it as kind of a spatial way of basically aiming at yourself through the boundaries of the horizon at infinity. And I always thought that probably there is something to it. Daniel, who is a very great mathematician, has been skeptical about the value of this topological property in pre-reflective self-consciousness, and then started proposing that we instead explore dualities. And he convinced us that there was something there. But what you are saying, go back to this initial intuition. Ken knows it very well because we wrote about it. So I'm actually happy that you are making this point, because I keep thinking there must be something. If it's true that we have this kind of projective way of, at least at some level, at some fundamental level of processing, information, so to speak, then that properties of these kind of topological properties of this geometry, even if we don't see it, because usually we see at the horizon the sky, the star, but the structure is there, it may actually play a role in this kind of self-observing sort of vanishing self-observing experience. So I'm glad you talk about that, because then that's, to me, it's the most obvious way. It has always been to make connection between this kind of circularity and self-reference. Duality is another way of approaching the problem. It's certainly a good one, and probably both interact. But so if you were let's assume this thought experiment that, think about a being that would has this fundamental way of representing, quote unquote, it's the world, that is, its consciousness would be structured by this sort of projective geometry. So if now we consider these topological features that you exemplified with the plane, do you think that we would get something that would be like to a property of observing oneself, but in a spatial fundamental manner?
So you're asking if we started with a being that was somehow fundamentally projective in its way of being, would it become self-referential in the way that we understand that?
Yes.
In relation to the geometry.
Yes, and in particular, this topological feature of antipodal point identification.
I don't know.
That's an hypothesis that keep coming back to my mind, and I can't decide, and I don't want to throw it in the trash yet. But I'm glad I can talk to you about it, because maybe.
But it may be worth doing some exercises in the geometry to understand what happens, right? I mean, projective geometry in the plane is completed by putting the circle at infinity in the way we were talking about. It's completed.
Yes.
Theorems that you write about configurations in the plane, if you send certain points to infinity, they remain true as you go off to infinity. And if you do some exercises, drawing pictures, looking at it, you begin to get a feeling of the reality of that line or circle at infinity. It's quite remarkable. You can't. The only thing to do is to say to somebody, well, do these exercises, follow it. Like,
but we have done so.
Bake this cake, and then you'll feel that, right?
Yeah, it's harder to do in the plane. It's easy. In 3D, it's a little bit harder. And one of the concerns that Daniel had is that it's non-orientable, and in 3D, and basically it's like if you have parallel lines like that, at infinity they arrive like that and they cross. And so that means that, you know, if you think about, for instance, a little mannequin, a little, you know, person represented in this in projective space, and you move it toward infinity, it becomes a point, and then beyond the plane at infinity, it's kind of reversed, upside down and left, right. And to Daniel, it was counterintuitive to the phenomenology of self-consciousness. But to me, it's not about actually representing objects or explicit forms. It's more about the loopy structure that it entails that give this sort of, you know, if I go there, I can come back to almost to the point where I am, basically, as an observer, quote unquote. Of course, the observer is not in 3D, it has to be in 4D, so it's more complicated because it's a set of rays. It's only a sub-model of the observer that is the model we use for painting, for photograph, where you have a point that is your projection point, and then you have a plane that is your projection plane. But you have to think about it in our model as actually this is embedded in a 3D model, and actually the observer is outside of the space because it's in a 4D space. But nevertheless, there are those great circles, and I think that those great circles have to do with the feeling we have of this kind of somewhat vertiginous sense we have of self-reference as a going back to ourselves in space. It's kind of elusive as an intuition, but it's an intuition that you can find throughout many traditions in phenomenology and in philosophy. So we have been trying to work on that. Anyway. So it's a good discussion. Maybe Grégoire is late.
I think it's cool. I think it's the longest session, and thanks, longest session we ever had. So that's great. Everything is online, so if I can edit if we would like, but I think you tell me. And it's very late for Louis, so thank you a lot for being there.
Thank you very much.
Thank you. Right. You are in the US, Louis?
He's in Japan.
Oh, in Japan. Okay.
Oh, in Japan. Okay.
It's 4 a.m. So
yeah, it's getting towards 4 a.m.
Oh my God, poor Louis. I'm sorry. Oh, thank you
tomorrow,
so much.
I can sleep late.
Thank you so much, Louis.
Well, thank you. It's been a beautiful discussion. I really appreciate it. I'll send you a copy of my slideshow. I mean, I'll send it Grégoire a copy of my slideshow. So maybe that will simulate some further discussion.
Yeah, I would really want to have other opportunities, and I'm sure Ken too, and I'm sure Grégoire too, and everybody here, but to, you know, just think with you.
Yeah.
Great.
Fantastic. And I'm sure it's kind of, you know, it's kind of a way for me to going back to Francisco in a very concrete manner. It's kind of, you are here.
So,
you're real.
Louis, you studied with him when?
In 2000. You know, he died. He died
yeah.
after I started my PhD with him, and he died after a year. Sorry, I have teeth missing because I just went to the dentist. They are going to put something back, but yeah, and you know, it has been and I have kept thinking about it for long. And we wrote a paper with a student in 2003 to kind of summarize all his work. Your work with him is quoted in there. And you know, it has deeply influenced me in the way I think today, in the way we think, even though it's kind of slightly different. And I wish he would be there to have this discussion with us.
I wish too.
Yeah. So thank you so much, Louis.
Yeah.
And see you next time, very soon, hopefully.
Okay. Thank you.
Bye and good night.
Good night. Or good morning in my case.
Yeah.
Good morning.